Welcome back, everyone. This is Mike Gibbs. I'm joined here by Mark Milovanovic, and we are here for day 6 of the Certified Cloud Security Professional Bootcamp, brought to you completely free from Go Cloud Careers. My name is Mike Gibbs. I am the CEO of Go Cloud Careers. I have been every kind of architect you can think of for the last 25 years. Network architect, security architect, enterprise architect, business architect, and cybersecurity has always been near and dear to my heart. So I love going through these kinds of boot camps, and it's completely free. So I hope to have you back. I'm glad to see you, and welcome back. I'm going to turn it over to Mark Milovanovic for a minute. He's our Chief Technology Officer. He wanted to talk about some new exciting statistics he thought you might want to hear about. I'll reorient you where you are in our completely free accompanying CCSP book and how and where to download that book. And then he'll finish up some housekeeping about other maybe free webinars and things, and then we'll kick off and have fun again.
Hello, everybody. I can't tell you how excited I am. We all hopefully had a refreshing weekend where we kind of let sink in what we went over last week. It was a lot of information, but very good information. Now, before I go into some of these new statistics that just recently came out through a study that the IC Square, the same organization that came up with the actual examination for the CCSP as well as the CSSP, what I would like to everybody to do is we generally have a free webinar on Thursdays that deals with on how to get your first cloud architect job. If you're interested in something like that, where you learn what the non-technical details of the role is. If you want to ask Mike on what a roadmap is towards being able to aspire towards becoming an architect, including a cloud architect, be sure to join us on Thursdays. The sign-up link is going to be in the description box. And as always, this is going to be on Zoom, which means you can come off mute. If you have a camera, you can join us via camera as well. And we can actually do what we architects do best, and that's have conversation with you and try to see what your unique needs are and how we can better help you gain the skills that you need from a technical and non-technical perspective in becoming an architect. In this case, specifically a cloud architect. But if you're interested in security architect, network architect, application architect, we'll be glad to have those discussions with you too, because the actual requirements are interwoven between the different roles. Some of the technical aspects change, but generally they're somewhat the same. If you want to get some additional information though in the meantime, in the description box, we also have a link to a free ebook that's going to give you some overview in regards to how you can get your first architect job as well. So pairing those two together, you're going to have a wealth of information going forward. And in either case, we hope that you're going to be there and have a great conversation with us. Now, what is the great news that I have? Like I mentioned, IC Square recently came out with a study that they performed, and this is a 2024 study, and it contrasts also what happened in 2023. And what they specifically brought out, that there is an increase of about 19.1% demand. Think of that in a single year when it comes to the security professionals that are needed, not to exceed capacity, but just meet capacity. That would mean, in very simple terms, we need 4.7 million people just to meet the current demand. How does that apply to you, to myself, to Mike, and everybody who's here today? They need competent people. That's why we put on this bootcamp as well, to help you gain the necessary skills. In this case, in regards to cloud, but we know that cloud and security in general is pervasive. So that goes across a wide spectrum of different areas, especially like today, we're going to tackle some software development lifecycle. We got application interfaces. We already discussed some containerization, some virtualization. So as you can see, security kind of goes through a web and flow when it comes to all these different things. But here was something interesting in the statistic. Besides that, there's a 19% increase in demand. They gave both technical and non-technical individuals a questionnaire. And out of this, surprisingly, the non-technical audience was dominating the technical audience in regards to and I'm going to give you about the top 4 things that they're looking for in security professionals. The first one, which topped out at 34%, is artificial intelligence and machine learning knowledge, but more specifically on how to secure these systems. Then next, specifically at about 30%, that deals with cloud computing security. So it's very applicable to what we're going to be further discussing today and then in the oncoming days in this week. Additionally, there was a 27% in regards to zero trust implementation. Now, zero trust wasn't a huge type of framework discussion within the CCSP, but it is something that every cloud provider implements in their own designs, and something that you as a security professional, especially as an architect, would have to be familiar with, because that is basically the future towards a framework on how to implement and design security we're going towards. And then lastly, something that we're going to be discussing a little further as we go on in this week is also going to be digital forensic and incident response, something very important and critical when it comes to a security architect. So what I want to tell you, everybody that's here, if you know somebody else as well that is interested in it, make sure that you share the various sessions of the bootcamp that we have, is that you're making the right decision by investing your time, your energy, and your resources in attending these sessions. You're going to gain a lot out of them, and as you see, there's going to be demand for you. Now, before I hand it over to Mike again, for those that have been here already, I want to make sure that you open up your study guide, the free study guide. If you don't have it, we'll put a link into the chat box, and as well as you can grab it also from the description box. This study guide is going to serve as a complement towards these sessions that we'll have. You can also use it, as I mentioned, as a study guide. It's also great for a slide deck. So if you want something visually as you follow along and you hear these key words as Mike mentions them, they're going to be fantastic. Once you have downloaded the study guide, make sure you turn to page 208, and we're going to start with these with the actual. Let's see, it is the actual section is going to be application programming interfaces. That's what we're going to start off, and then eventually we'll progress slowly towards not necessarily something that we're very well versed in always, but we still need to know how the software development lifecycle works in regards to the security and also the cloud services. So I hope everybody is excited for today's session. To let us know that you had a great weekend, that you're excited to be here, please in the chat box put a hashtag CCSP. Let us know that you're here. And I already saw that many of you also told us that you're from different areas of the United States. I see also that we have Mark from London, UK. We got, of course, Mark Yoshikawa from the San Francisco Bay. So let us know where you're from and give us a hashtag CCSP to let us know that you're excited for today's session. And with that said, Mike, I hand it over to you, our fearless leader in security, and let's get this session started. I think you're muted, Mike.
Wonderful. I am going to address Mario's question very quickly in the chat box. And normally I wouldn't answer it now, but I'm going to answer it for two reasons. So Mario asked if we have live courses or study groups. So Mario, first, we do have live courses, and we train lots of cloud architects, cloud network architects, cloud security architects, and we can talk all about them in the webinar we have on Thursday, and my team will drop a link to that, and we'll cover the skills, also the way we teach it, but even if you're not with us, what skills you need to learn. But I did want to caution you about study groups. So all of our programs do have study groups, but the key is they're taught by experts, people that have been in the field for decades, and the people in the study group have all been taught correctly. I remember when I was doing my CCIE, I was part of a study group, and here was the way we actually did our study group. We all got together, everybody was pretty close to CCIE certified already, and somebody would actually teach a concept. And then when they went through that, we all brought our books, and then if they made a point, we would say, where was that? And they would show us the exact proof of where that was, because most of the information out there, I'd say 80 to 90% is wrong. So if you're part of a study group, and in that study group, and they want to talk about ARP, and then they go and they talk about something, and they can reference, for example, the Stevens TCP IP book on ARP, and then they can reference the RFCs from the IETF on ARP, and all the IEEE specs, how Ethernet would deal with these things. That would be a good study group for you to join from. But be very cautious of those where it's most people that watched a YouTube video that was taught by somebody that never had a job who was then taught by somebody else. And unfortunately, the group goes around and around and around, and it's so sad because they work so hard, but they can never get ahead because they need a guy lead of the group. So just keep that in mind, that with study groups, if they're not mentored. So we'll get back to the content, and I love the concept of study groups, and I have study groups that we've created all over the world, but they all have people that are all trained right. So just think about that wherever you get information. Always question the source. I really want you to. Anytime you think about it, who created the study, what's in the study, or the study's methods accurate, and that way you'll think like yourself. You come from a non-biased perspective, which is exactly how architects think. So we're going to now get into APIs, application programming interfaces, and both Mark and I are definitely not application architects by any stretch of the imagination, nor software developers. But it's part of the CCSP curriculum, so we were going to discuss them. So, APIs are fairly important in today's world because they enable one application to connect or integrate with another application. And if you really think about an enterprise that has 200 to 1,000 different applications, being able to get their applications themselves just to talk to each other is important. Plus, an organization may have to connect to other extranet parties or third parties or supply chain providers and then other environments where they're going to have to exchange information with them too. So APIs become very important in application development and the applications and application integration. So why is that an opportunity? So if anytime you're going to integrate two systems together or connect one system to another system, that interface itself could ultimately become a security risk. So when we think about APIs from the CCSP perspective or from a security architect perspective, we're not actually going to be thinking about what we do on APIs. There's other people that typically do that. But we have to think about what are the vulnerabilities in that API. And if that API is compromised, what could that actually do to the business? And what are the methodologies we can use to actually secure that API from the threats that exist? So we're looking at it more from that perspective. But if we understand that APIs are used for integration and business is full of integration, and every time we have to connect two things, there's an opportunity for attack, that'll get you to think about API security. But two applications, two companies connecting. Intranet going to the internet with a firewall between them. Anytime you take one system that's known to be safe and you connect it to another system that is never known to be safe, you're in that point where you're going to need security. And you can think about that from an API integration, taking a delegate if you were doing executive protection from point A to point B, you still have to think of those same things. So let's talk about a RESTful API. So it's a type of API. It's fairly common in web applications. And it stands for Representational State Transfer. And REST APIs are really designed to scale web-based applications. And they typically use some guidelines and some best practices. The characteristics of these types of API is that they're fairly lightweight with low processing or overhead kind of traffic. It uses very simple URLs. And it's not really reliant on any type of a programming language, so it tends to scale well, and it can provide outputs in various formats like XML, JSON, etc. So fairly common type of API. It uses something called HTTP verbs, and if you come from a software perspective, you'll probably know a lot more about those than we would, but these types of verbs are things like post to create an object, or get to read data, or put to update or replace data, or things like patch to modify an object, or delete to delete an object. And it's fairly efficient with regards to smaller messages compared to other alternatives like SOAP type interfaces. So REST APIs are typically used for environments where it's low bandwidth that's needed, or limited bandwidth, so you want to be as low overhead as possible. Applications that are stateless where they don't keep information about each other. And anytime caching is needed, the RESTful API can work out fairly well for these types of applications. Now, the next type of API we're going to talk about is something called a SOAP API. And that stands for Simple Object Access Protocol. And it's a protocol specification that's about exchanging very structured information in web services. So it can work over common protocols like SMTP used for mail, FTP used for file transfer, HTTP obviously for web. It's standards-based. It typically relies on XML. And some things to think about are some characteristics of this type of API is it's fairly intolerant to errors. It's also slower than REST type APIs, but it does have some built-in error handling. And it's typically well suited for when asynchronous processing is needed, to format contracts, or for stateful operations. So if we start thinking about some API considerations, neither REST nor SOAP is inherently better than each other or more secure. And we have to remember that, and that is the key with all architecture guidelines. There is no better technology, best technology ever. There's the right tool for the right job, and when it comes to architects, there's lots of tools for the job. So we have to think about that. Now, one thing that architects in this space, specifically application architecture, should be thinking of is APIs grant another application access to any application and its data. So if we think of security from day one, the people that are architecting the application should be able to think about this thing is now connecting to this thing, and now it can access this thing's data. So security needs to be part of the application. The way the code's written, obviously speaking, these APIs. So every part of everything that connects to anything needs security. So we've got some concerns. When we have integrations here, we could have data leakage, for example. And if the API is not really vetted and secure enough, we can have all kinds of security issues related to that. So think about all this. And you're going to have to think about this in the context of all the storage and all the information flows and all of the networking and storage in the compute, and even sometimes separate spaces in DRAM. And I don't want to say that to be overwhelming. Actually, I want to make it sure that it can be underwhelming for you. Because if you want to be an architect in security and you realize that it's that big, realize there's going to be areas you can specialize on. For example, my expertise is network security. But security can span a whole bunch of different careers. So realize that's why as architects we build architecture teams. You can build a team of all the experts you need to do to get the best, do the best job for your client. So if we look like we're going from APIs, which we are, to next generation firewalls, to IDS, IPS systems, we are, because it's the whole spoke of cloud security. And this is more than one person's job. So don't be overwhelmed by it. Now, let's talk about public APIs, and they're basically used to provide services to external users. And they typically are there for third-party integration. And sometimes these public APIs are licensed to the point where basically every time it's used, you pay a fee, for example. These types of APIs kind of need security to guard against misuse and overuse. That's a public API. So let's talk about a partner API. So a partner API is used for one business to provide integration to another business. But these two businesses have some form of an established relationship. So partner APIs are used for business partners. They're used for shared business processes, which work across various systems. So the business does something one way, and it has to touch various things along the way, and that's where we're going to use that, because we won't be using the systems of one provider and another provider, and they have to talk to each other. Now, when you start opening systems to other companies, now if they get hacked, you can get hacked too. So that's kind of a shared responsibility between both organizations, and you can never truly rule out another company and their security because you have no control over it. So you may need to think about a lot of the inherent security risks that you have coming in, and how would you protect that API. You always need to be thinking of these things, actually. Now let's talk about private or internal APIs. Now, these are APIs that are designed for use inside of an actual company. So it's not going to be available to partners. It's not going to be available to the public. And it's going to be exposed via an internal API directory. And that can therefore basically use much of your identity and access management for integration, because they're already on your network. So you've got a lot of security related to them already being there. They have to, they're not, it's not like they have to go from the internet to your network, and there's challenges to do that. Now, some people can do it, but it's hard to do public versus private network because you've got a boundary there. So now they've got to be in your systems. And then when people are already in your systems, then we fall back to the only security things we have, or one of the only things we have, which is identity and access management. So we can heavily use that on these systems. So we can secure them that way. Now, of course, we could provide network security to them and things inside of our systems as well. I don't want you to think that's all we can do, but now we've got good IAM, which we can actually use, and they're protected users on the system. So IAM being like a last line of defense, it's still much safer than IAM is only exposed to the public world. So let's talk about some common API threats that come out there. There can be things like injections in attacks, or a denial of service attack, or a distributed denial of service attack. And here's what's really going on with the denial of service attack. If I've got an API which can handle 5,000 messages a second and deal with it properly, and now out of nowhere I'm sending it 500,000 messages a second, the API would be so overwhelmed by the denial of service attack that it can't respond to legitimate requests. Now, a denial of service attack is I use my computer and or a hacker uses their computer and they compromise the host directly. A distributed denial of service attack is where one hacker compromises, 1,000 computers on the internet and then uses those 1,000 computers to launch an attack to an organization with the whole goal of taking them down, or overwhelming their systems so much that you can find a security hole during them when the systems are stressed beyond their belief and then get in. One of the two, typically. So another concern, a common API threats that you find is fairly poorly secured API services and API servers. You'll see that all the time. You may see credential attacks on the API, the wrong username, password, so to speak, or compromising that. You may see accidental API key exposures, which is something you obviously don't want to happen. You can see people take brute force attacks where they use a computer to generate random usernames, passwords, that kind of thing. And you also have to be concerned about poor API key generation techniques. So let's talk about some security best practices we can think about. We always want to implement authentication and authorization using API keys. So what does that mean? Authentication is making sure that the user or person is who they claim to be. So System 1 wants to talk to System 2. Are you, in fact, System 1 that's allowed to talk to System 2? The authorization is when this system wants to talk to this system. This system basically says, request permission to do something, and then is allowed to do it. So I hope that kind of makes sense. So we also want to think about that. We want to basically do what we always did in networking, which is called rate limiter or throttling. And in networking, for example, if I had a host that was sending a ridiculous amount of data, and it was taking down the rest of the users on the network, what I might do is limit them to, say, a certain amount of bandwidth so other users could be there. Now, we do similar things on APIs. So if we know an API can only handle a certain number of requests, throttle them or limit the number of ones that you're actually able to receive so you don't overwhelm the API, and much like a DDoS attack. So that's throttling, which we can use to help protect our systems. And I kind of hope that kind of makes sense why we might throttle things or why we might rate limit things so we don't overwhelm systems. There's other reasons we might throttle messages too from a TCP/IP optimization perspective, but things like weighted red are probably way beyond the scope of the CCSP. So some more things to think about. If we have APIs, we need to conduct regular security audits of these APIs. And we need to maintain as an organization an inventory of all of our APIs and what do they do and where are they connected and how are they patched and how are they secured. Really keep that up to date. There's some additional security best practices for third-party APIs. You really want to maintain an audit trail of where these APIs are coming from. So think about where they're coming from. Are they coming from somebody that's tested it that you trust? If so, do they have documented release cycles and bug notes or something that's being released with the API? Is it something that's been found free on the internet that you don't know and you better test it really securely? And sometimes what you find free on the internet can be great, but sometimes not so much. Same thing when your developers pull code. That code needs to be security checked. We'll get to that later. But make sure you properly handle any type of API keys. Like anything else, your security keys, your encryption keys, you got to keep those things secure. And you have to plan what would happen if you've got a third-party API and that's integrated into half of your applications in a business, and all of a sudden that API was discontinued. What kind of impact would that have to the business? And these are the kind of things and the risk that architects plan all the time. Multi-tenancy is next. But maybe here's a good point to stop, see if there's any quick questions, and then we'll answer them quickly, and then we'll get back to the content.
All right, let's take a look at some of the questions. So first question is from Kennedy. They're wondering, well done, Mike, for your impactful lecture delivery. Please, what security risk is associated with the use of partner application programming interface, so APIs? So for you, Kennedy, in general, it's going to be exactly what Mike already mentioned. So since we have to trust, we have to have some kind of inherent trust with our third parties, they're going to have the same attack surface or attack threat surface that we have as well if we're using private APIs as well. Now with public, these are generally going to be shared across customers and so with our vendors. So we have injection attacks that we have to be careful about. There's always going to be the risk in regards to poorly secured API servers and how they store the particular keys, the API keys there. We're going to have what they call an on-path attacks as well, where we can get a different attack vectors from that perspective. And then something that you can never, ever rule out is always going to be denial of service attacks against a particular server that might be storing our API keys. So, and then lastly, this is something that is not always called out for, but you also got to keep in mind, generally speaking, API keys are going to be distributed to some type of employee or otherwise some type of group. So actual lack of proper best practices on how to handle the keys themselves among a particular group role is also going to be crucial, because that means that there's a lack of proper training when it comes to these individuals. So that would be one aspect of what are some of the additional issues that you might be facing with vendors or third-party vendors. All right, question from Mario. They're wondering, what all responsibilities for CCSP? Is it just security on the application level or layer?
Okay.
Mario, go ahead, Mike.
Let me touch this one because I think I was interpreting it as it came in a little earlier. So Mario, I want to make something clear. So if you're asking what are the responsibilities of the CCSP, as assuming it's a job, the CCSP is a certification. And going from a certification to a job is going to take a lot of steps. And it depends on the career you actually want. So we will set a time where we'll actually career questions. I promised I would set up a 2-hour session on Zoom live to actually do that. And I am totally happy to do that. And I'll have that set up inside of the next week where we can talk about it. But you have to understand, for example, if you want to be a security architect, and we'll cover that on Thursday's webinar, which you can join for free. It's on Zoom. That's one set of skills. If you wanted to be a security engineer where you could still have the CCSP, but you're working in a defensive position, that is a completely different set of skills that you will need to learn. Completely different, 100% different. And by comparison, if you wanted to be a security engineer that's CCSP certified working in penetration testing or ethical hacking, that's going to be another set of skills that you need. Or if you were going to do an analyst type role, which is a really junior role, that would be yet a different set of skills. So I want to make sure we're not confusing a certification with an actual job. The certification is credentials, but the job is typically something that's a little different. So I want to make sure we can address that for you when the time comes with the correct knowledge.
A question from Mark. It says, is there a term for an attack designed to accumulate billing where the attacker has determined your site pays per request? For example, I've seen the phrase bill shock used. The term that you're going to be looking for, Mark, is something called economic denial of sustainability attack. That's generally what the term is. Now, you mentioned accumulated billing. You might even hear this on something called a billing bomb as well. So this is basically where the billing bomb will overwhelm, a service with requests and resources in regards to basically generate a lot of excessive billing costs. So this is generally what you're going to be referring to. So again, remember, it's called economic denial of sustainability attack. A question from Kennedy. They're saying, considering the fact that cloud architecture has trusted, genuine software, firewall, and other necessary infrastructure, why is it still possible for hackers to compromise the system? I'm going to put it this way to you, Kennedy. Everything that you mentioned, number one, from software all the way to hardware, they all have different levels of softwares running on them. Sometimes it could be something like a basic input and output service, like a BIOS. Sometimes it could be some type of firmware. We could be looking at some type of network operating system or firewall operating system. All of these are going to be based on programming languages. And since people are the ones that generally are integrating these type of systems, and with the help, of course, of AI, we see that there is ways to bring about code, mistakes can happen. And these mistakes, these vulnerabilities can, of course, be exploited. But something else that can also happen with any of these is that hackers and other people or threat actors that come in, they will always find ways to twist and turn already working services. Yeah. One of the easiest examples I'm going to give you, because I'm going to let a little bit of the movie geek out of me. If you think of like the movie The Matrix, the one, the Keanu Reeves that played him, he had the ability to take a working system and then manipulate it to allow himself the leeway of making it and shaping it to what he wanted. Again, this is what hackers can also do when it comes to all these different type of softwares, especially also the infrastructure devices. That's a very simple example of why there's always a way of compromise when it comes to a system. And before I forget, one crucial reason also this keeps happening, I have to go back into my CISSP days, is this idea of social engineering. Believe it or not, people can be a weak link in the chain. And because of that, this is also a way that hackers and other people are able to exploit that type of resource.
Yeah, and I'm going to add to that a little bit. Here's the thing. The thing to always remember is not only is nothing perfect, but the people that assemble these systems in most cases don't have the knowledge that are necessary on how to assemble them correctly without actually having it. So we have a big user issue. We have that, and we have to also remember that, bad actors are everywhere. And as hard as we work to actually create new means to stop bad actors, they're trying harder to attack you. And everything in life has a vulnerability. So I've studied martial arts for 30 years of my life. Something comes at me, chances are I'm going to get out of the way. But not always, because maybe an attacker comes to me with a new attack that I've never seen before in my life. And it surprised me, and I couldn't see it or I couldn't sense it because it was an art that I was not familiar with. So the real key is, and honestly, if you think about it, it's the same reason why we can make a fireproof house, right? We've got fireproof construction materials. But yet, no matter what, we still need the fire department because we can do pretty much everything right and make sure things are fire resistant. And then somebody's going to ultimately be in their backyard and somehow do something that's going to cause a problem anyway. So that's really it. So I kind of hope that summarized it. As hard as we are working to protect it, there's many people working just as hard to break it.
From Mario, do you have to know some networking for the CCSP? Mario, you will, and I know a lot of people are going to not like what I'm about to say. In any profession outside of networking itself, you will have to know the basics of networking. You're not going to get it around. Number one, think of it like software development. Most software today are going to be some type of applications that are either going to have some type of accessibility when it comes to the public internet or some type of web access internally. So either way, you will have to know the basics of what type of protocols you're going to be using, how to optimize the software for these protocols. If you're sharing, let's say you have discontiguous storage, meaning the storage is not actually connected to the application and its server, you will need some type of network to be able to communicate to the storage and the databases, etc. So yes, you definitely will need to know some networking.
But don't be scared by it. As long as it's taught right by people that know networking, it'll be easy. It's only challenging, and you'll see it challenging for many as, there may be 5 to 10,000 really good networking people in the entire world, and they can explain it and make it sound so simple for you. And when you see that, it'll be nothing. So we'll make sure you understand it well. But you do need to understand it.
Yeah. So from Ivan, they're wondering, can you tell us what is the best practice for storing API keys? Ivan, a little bit later, I'm going to provide you all with a link to a document from the NIST institution. It's going to deal a lot when it comes with the software development cycle, and it's going to include some details. But just know when it comes to best practices of that, something that you always will be necessary to do is going to be encryption, both at rest and in transit when it comes to these keys. So besides that, there isn't very much more that you'll need to know necessarily for the CCSP exam, but I will provide everyone with a link to the document later on that's going to go into much more depth in case you're curious about the details. All right. And from Cloudy, are REST and SOAP the only APIs that are covered in the CCSP exam? The answer to that, you want to go ahead, Mike?
Why don't you cover it, Mark?
So predominantly, yes, these are the two only that you will need to know about. Now we'll put it this way. For real world scenarios, and when you actually go work for somebody, the other details that you will need to know about these two APIs is really the use case for them and why you would use one over the other one. For exam purposes, it's not so necessary, but for real life, you'll definitely want to know that, for example, REST API is better performing. It has more data formats that you can use. But on the flip side, something like SOAP is going to be a lot better when you need stringent security requirements, such as if you have healthcare or some crucial government entity. And it's going to be a lot more, how would I put this? It is a little slower than REST API. So those are little things you'll need to keep in mind with it. But for the exam, these are the two that you predominantly will need to know at high level what they are and not necessarily how they work in detail. From Nell_Sun06, outside of authentication, authorization, and throttling, and rate limiting security measures, sounds like you took away all of our options already. What are other security measures at the API gateway, caching and backend API communication level to the input daemon? I'm assuming that it means IMTU. Yeah. So I'll mention one, Nelson, and then I'll let Mike give you the architect answer to that, because I have a good idea what he's going to tell you. When it comes to what outside of these things, you kind of took away, this looks like a test question, by the way, what you gave us. You took all the nice options away. Really what you're going to be looking at is basically input validation and sanitation. That's really one of the main things that you're going to be looking at. That means whatever data is coming in, you want to make sure that it conforms to expected format. And additionally, you want to make sure that anything that you might have some kind of strict schema when it comes to the validation, then anything you actually have in input patterns is going to be whitelisted. Aside from that, you did not necessarily mention confidentiality in that, so I'll mention it again. It's going to be data encryption as well. That's going to include both at rest and in transit. And for things like that, of course, you're going to use either just TLS itself, or more preferably, you're going to go with mutual TLS. So this is something that we described last week in regards to server and client, how they can mutually authenticate themselves as well.
And I would also add there's other things we can do from the network perspective. For example, we could put our APIs in a certain subnet and potentially protect those with firewalls or access control lists or other things. So there's always more that we can do. But you listed many of them. We have one more question to go.
Yep, let's take one more and then we get back to the content. This is from Yasel. If hosting APIs on virtual machines, and these APIs need to be consumed by several third parties, would it be a good practice to place those virtual machines in a DMZ, basically demilitarized zone? So it is generally good practice if you're going to have assets that require access to a third party, that you do put them into this demilitarized zone. So this demilitarized zone is going to have less stringent security requirements, but at the same time, it's not as wide open as even if you place, let's say, a web server into your DMZ. So generally speaking, it is good practice to do so. Now, there could be a plethora of reasons why you may not want to do that as well. That's going to be coming with integration, and of course, depending on your vendor engagement and what type of reputation and rapport you have with them. But generally speaking, always place everything in a DMZ if there's going to be some type of outside access, and then follow best practices with encryption, keeping the key safe, etc.
And while we're at it, we typically have one type of a demilitarized zone we think of when we connect to the internet. This is going to be a completely separate type of DMZ that's going to be connected to third parties. And truth be told, we can have one DMZ to connect to all the third parties. In a really high security environment, we might have 100 different demilitarized zones, each connecting to somebody else that's all firewalled off between them. So this again goes to the kind of requirements we have. What are the goals? What are the needs? And these are architectural options we have, but there's never a best practice. There's never an approach. It's all about what problem are we trying to solve and why. I hope that makes sense. Great question there, and very good thinking.
All right, let's get back to you, Mike, then.
We'll get back to the content. Let me know that you are awake, you are alert, and you are oriented by giving me a hashtag CCSP. If you're having a good time, hit the like button. If you're learning something, hit the like button. If you're not a subscriber, please subscribe and hit the bell to be notified of new videos. And who knows? Maybe we have more free training coming up someday soon. So you won't know that unless you're a subscriber and you've actually hit that bell to be notified of it. So we will get back to the content. Join us Thursday and learn how to become an architect. We will go over the role, all the things in an architect, and you'll have the complete set of skills that architects need to be successful in their lives. And at least half of them are non-technical, so we'll list them as well. So hope to see you in some free webinars. So we're going to talk about multi-tenancy. So I know I've talked about this before. So multi-tenancy in the cloud is where so many of you are sharing the same space. So again, data center, you own it. Again, cloud, public data, so they rent you space in the data center, much like a hotel in case you've just joined us. So if you think about it, if you're staying in a hotel and the hotel says has 500 rooms, and an attacker were to compromise and hold that hotel, you are attacked because you are inside of that hotel. Now, that's completely different than the risk of a bad attacker coming to just your room to try to attack you through the room. So in your house, you have the equivalent of being attacked in your house, which is the same risk as being attacked in your hotel room, roughly. In the hotel, you have to worry about the hotel being attacked and your own room being attacked, but all of a sudden assume the hotel is a big target. So because of that, we have to think about what kind of isolation we can provide ourselves in the cloud. And a lot of this isolation is at the very software level. So hypervisors, for example, on systems. So what we need to do is make sure that there's a logical isolation of our stuff from everybody else's stuff. So that we have to design our systems knowing that breaches or outages, they're just going to occur. And we need to know ahead of time that we might be exposed and not put our head in the sand and think, okay, it's going to be just fine. No matter whose technology you use, I promise you, it will fail. Now, how that technology provider deals with it when it fails is another thing, and how you architect your system. So when your cloud provider fails and one of your firewalls doesn't work, do you have another cloud provider? Do you have a backup set of firewalls that are behind the primary firewalls? That's your decisions. That's the architecture piece. So plan for the bad things to happen, because they're going to. So now we're going to talk briefly about firewalls. So we're going to talk about web application firewalls first. The whole point of a web application firewall is it is going to protect against web attacks. And it looks pretty specifically at HTTP and HTTPS traffic. And it relies on a policy to analyze traffic, just like any other firewall that you might actually ever find. And it'll enable you to filter traffic based upon live sessions and context. Most web application firewalls have very good nuanced control over web traffic. They typically have default rules which will stop common attacks. And they will just common attacks, for example, like an SQL injection attack or a denial of service attack. And there's going to be a couple of kinds that are going to be out there. So you'll have the kind from the cloud providers that are the cloud native tools. AWS WAF, for example. All the cloud providers have their equivalent. Cloud provider made by the cloud provider, native to the cloud provider, they can recognize a known attack, and they can stop certain known attacks if you subscribe to third-party services in addition to them. That is the cloud provider's WAF. Now, there are also next-generation firewalls, third-party provider WAFs made by security companies that do a lot more. Not only do they block in everything we're talking about known attacks and blocking known attacks like SQL injection attacks, not only filtering at layer 7, but these things can actually recognize patterns of behavior that attacks that it's never seen before and block them in real time in many cases. So in most cases, we're multi-cloud, 98% of cases. The cloud providers' web application firewalls typically don't come anywhere near the type of security we can get from these next-generation firewalls. Maybe we consider more next-generation firewalls. But again, what are the security needs and what we're protecting? But if we go to the third-party marketplaces, like the AWS marketplace or the Azure marketplace, we can get some very good, very industrial-grade solutions for web application firewalls. And we can also deploy these same firewalls in other clouds, making it very common for our team to only have to deal with one type of firewall or two types of firewalls. And we can use those same two types of firewalls in all clouds. I want to briefly talk about database activity monitoring. And the functionality here is it's going to combine network data and database audit information into something we can look at in real time. And it's going to analyze database activity for unwanted or anomalous data or unexpected behaviors. And it's going to monitor application activity and look for privileged uses where basically you sign you upgrade to a super user or administrator, if you will. And it's going to look and find attacks using behavior analysis or look for things that don't look right. Now, it's often available with some of the cloud providers' databases. They typically have some form of a database activity monitoring tool. You may see them with XML firewalls. The purpose here is to protect services that rely on XML-based instances, like many web applications. The capabilities here are more validation and filtering. And they can rate limit, meaning slow down the amount of it that's coming in and protect traffic flow from certain protected resources. Now, we'll talk about API gateways, and their point here is to basically monitor, manage, and aggregate APIs and connect them to other things. So they're typically used for authorization, access control, and traffic control and throttling to the APIs themselves. And we can typically provide some filtering capabilities and as an additional layer of security to our APIs. Some other things we'll talk about are cloud access security brokers and how they fit into this whole cybersecurity cloud architecture piece. So a cloud access security broker is really going to serve as an enforcement point between customers and, say, third-party providers. And it's going to ensure that the cloud services that are typically used are going to match an organization's intentions. So it's providing identity and access management, meaning who are you, authentication, authorization, what are you allowed to do, and then accounting, what have you done. And by using a cloud access security broker, we can control service uses to only authorized individuals, which gives us a degree of data protection capabilities, and it can help us with threat monitoring and management. I want to briefly talk about the cloud software development lifecycle. And remember, this is a security exam, so it's not like they're going to be looking into you knowing how to code. They're just looking at, do you understand certain software life cycles from a high level, from an architectural level? Do you understand the basics of what are APIs and where their vulnerabilities are? Because we're not going to be working with APIs as a rule, as architects. We're not going to touch any technology as architects. We're going to be designing, presenting, leading teams, facilitating meetings, responding to RFIs, Ps, Qs, lots of requirements gathering, but not touching technology. So what is the software development lifecycle? So it's all the steps necessary from the time the idea of an application is conceived, basically to the time it's delivered, deconditioned, and a new one is created. Everything. So requirements gathering, design, coding, testing, rollout, user training, maintaining the application, and then decommissioning it in the future when you say it's just not needed anymore. And most enterprise level development follows 3 phases, typically speaking, even if it's informal. And and the way these phases can be implemented, and there's lots of ways that software development life cycles can be implemented. And the key here is to ensure some consistency in functionalities. And there's various software development life cycles that really would suit the needs of different projects. So it's about choosing the correct option based upon the needs of the project itself, like anything else. So what are typically the software development phases? So the phases are typically the planning phase. And this is where we evaluate the organization's the potential of the project for the organization. Is this idea going to yield some business results? Is this idea even possible? And what's it going to cost us to implement this idea? You have to plan first. We don't just build, we plan. Now, the next thing we need to do is figure out what are the requirements. Okay, if this is the business goals, how's the business going to operate? What are the steps necessary to deliver this product? If we're making an application for a sales rep, how does that sales rep sell? What stops do they need along the way? What information do they need along the way? How do we enable that sales rep to better do their job? Well, in any application, we need those requirements so we know how to make sure the application supports the business user, or otherwise it'll hurt the business user. So lots of requirements, and that requirements are business requirements, requirements on how it's going to be used, performance requirements, any kind of requirement. Now, once we know what we need to do, and first we looked at we tried to plan it. We tried to figure out the goal. Where are we trying to move the business? And then we gathered the requirements. Only now can we think about what are we designing? And this is where the functionality comes out, the architecture, but the flow of the way it's used, the architecture from its impact on the business, and the architecture from the technology things that are going to be necessary to get it done. And in order for the design, what's going to need to integrate with what? How's the data going to flow, and how does it integrate with the business processes that are there? So that all goes into the design phase. And those first 3 phases we're talking about, that's where the architects actually work. Now, the next phase is where the engineers come in, and that's the coding phase. And this is where the actual development and coding of the application actually occurs. And this occurs, designing the code and then unit testing the code and analyzing the code from maybe the source code or from a security perspective, and do code reviews as well. Then after it's coded, it's got to be tested. Is it really going to work? That's that QA kind of phase. And here's where the organization does some formal testing. And then maybe the organization gets it out of the QA department, and maybe they run the application themselves with their employees for a little while. Maybe they have various stakeholders test and utilize the application. Then maybe they stress test the application and run some kind of user acceptance testing and make sure that it actually works. And once the application is created and then it's tested, now it's time to train the users, because you can't just roll it out if people don't know how to use the application. The next day they're on the job and it's going to be, whoa, what just happened? I don't know how to use this stuff. So you've got to train your users on the software. If your users understand it, you need to actually install the software and deploy the software. And the software, like anything else, will have new bugs because something will happen in the world where there'll be a new vulnerability discovered. The operating system is going to have something that's going to need to be patched, which is going to go break the application, which is going to need to be recoded. Some other application that's commonly deployed on the servers that have the same things, or workstations that have the same things, is now causing a conflict with this thing, so there'll be some new source code patch later. So there's always going to be some maintenance on the software, some updating it, minor modification, those types of things. And then at some point, that software is just no longer useful and it becomes end of life, and you decommission it, where basically you shut down the old projects and old systems. Because we're not going to run systems that are no longer used when we move to something new. So let's talk about some software development lifecycle methodologies. So there's a couple of methodologies. The first methodology we'll briefly discuss is what's called the waterfall method. And this is going to be the oldest and most straightforward software development lifecycle approach, where basically the development phase follows this downwards like a waterfall through the system. And basically it starts with requirement analysis, and then system design, and then system building, and then system testing, and then deployment and maintenance. You may hear the building called implementation. And in each phase, one phase is completed before the next phase, and the next phase can begin. And that's waterfall. Now, Agile is another methodology, and it's a little more focused on processing adaptability and increasing customer satisfaction by rapid delivery of working software. So, Agile methodologies really encourage a flexible approach and the way the teams actually collaborate, and the way the cross-functional teams collaborate. Agile methodology is really designed to ensure customer satisfaction through every phase, starting early in this delivery of the software. And it's going to welcome changing requirements, even if they're later stages in the development. And basically, what's going to happen is software will be delivered fairly frequently in short time frames of weeks rather than months. And the key here is to promote some kind of daily cooperation between the developers and the business people that are actually going to use the software, that are sponsoring the software. You know, Agile, with regards to the Agile methodology, it's about building projects that are motivated around individuals and making sure the teams that are there have the support they need. It uses a lot of face-to-face conversations, as they are time efficient, and they tend to convey information much better than trying to use email, for example. They measure progress by whether the software works and the kind of software that's there. And it's more about a sustainable development pace. There's a continuous focus on technical excellence and good design throughout the process. It's really designed to emphasize simplicity and really maximizing the amount of work that can be done. And the goal is to allow best architectures and requirements and designs to really come from organized teams that are there, that have got all the right people involved, and to regularly reflect about how to become more efficient and how to do things better. I think there's some backlogs we should really talk about. So there's some things called backlogs that are part of Agile, and that's really going to be a list of features or tasks that are going to be required to complete a project. You may hear the term sprint retrospectives, and they're really just meetings that are going to be held at the end of sprints to discuss the next success and the next challenge and what improvements can be made the next time we have to deliver a piece of code. You may also hear of something called planning poker. No, I did not make up these terms. And that's an estimating and planning tool that you use, where you use cards with values to estimate the amount of effort required for various tasks. And that way you can reach a consensus decision on how much time it's going to take through the group. You may also hear of terms like time boxing in Agile development, which is allocating a set period of time, which they call a time box, to accomplish a task or a goal. You may hear things like user stories, which are going to be high-level descriptions of user requirements. You may hear about things called velocity tracking with regards to Agile, and that's really comparing the estimated effort for the current sprint to what it actually took to get the job done. And that way the team can gauge and learn from their planning efforts for future projects. Little things we should think about under the software development lifecycle, which is related to configuration management and versioning. We have to know the software we have, just like we need to know the hardware. In a data center, there's typically a bill of materials, this many of this server with this much capacity, this much of this. Well, we need to do the same thing for the software. We need to manage the software with like a good bill of materials list so we know everything that's there. We need to know what software we have, where it's configured, how many servers it's running on, what version of the software is in place, how the software is configured. Is there a standard-based configuration for security that was chosen based upon the needs of that business? So a common approach to versioning and the way naming conventions is typically a software version, say 17, for the major release. And then let's say there is another version like 17.5, and then there might be a patch. So you might see a 17.5.1, where it's the 17th version of the software, of the 17th new iteration of the software. The 5 is the 5th version of that particular set of software, and the 1.1 in the end would be like, here's the patch of this, and then until they go to the next phase. You'll see that all the time. The benefit here is it makes it easy to track the usage of current versions. And it's pretty easy to find out which versions of software aren't up to the standard or up to the newest golden image by looking at the versions that are deployed. And often you can use tools to make sure that all systems are patched to a certain version level. Let's talk about configuration management briefly and some critical aspects here. You have to know where your starting point is before you're going to do any kind of configuration management. So that means baselining the systems and getting a copy of where you're at. And with configuration management, you can set it up where you've got centralized changes of all your configurations. Specifically with the cloud, it's real easy. We can push infrastructure as code. And by doing it, if we've got a configuration that is our new mirror standard that we have to have, and then we upgrade it to something and it didn't work, we can revert back to the previous version we also had as well. So we now have the configurations of all of our devices. And this way we can track usage of the current versions. If an issue arises, we can find out which versions potentially are having a problem and maybe fix those and not have to think about the entire organization. So version control will help us identify patches which may come with known or unknown vulnerabilities we'll learn about later. Really managing configuration can take a lot of work. It typically is great for DevOps type roles, and because they're so involved in CI/CD pipelines and infrastructure as code deployment. Some things that an organization should think of with regards to configuration managers: what kind of tooling do they have in place? What kind of processes do they have in place? And what are the needs of configuration management for what they have? Okay, so let's talk briefly about cloud application assurance and validation. So with regard to we should be constantly looking and making sure things are right. Whether it's looking at source code at a certain point, or whether it's testing prior to deployment, or looking at things during the coding process, but we should need to be constantly monitoring things during that operational lifecycle. And we have to test the applications, and we have to test our code, because otherwise they won't be secure. And we should be very familiar with various security types of testing and tools. The starting point of that will be threat modeling. So I think now is a good time to actually start taking some questions.
Okay, let's see what type of wonderful questions everyone had this time around. So from Lee Two-Way, they're wondering, web application firewalls protects against SQL injections? They actually do, Lee. It's quite, you got to think of a web application firewall similar to just a normal firewall. It's going to monitor and it's going to filter traffic that generally is going to be, now this is where the specifics came in, between, let's say, the user and the actual web application. So it's not going to be as potentially robust as a standard firewall or even a next generation firewall. But the way it does this, and this is why we mentioned SQL injection, is it monitors, and then through signature detection, it's going to identify a potential attack. And if these input patterns, because that's what signatures are, they're patterns that it looks for. If they're recognized, immediately it's going to inject the policy on the web application firewall, and it's going to basically stop that attack dead in its track, so that it can never get to your database and cause any type of issues. Okay, let's take a look at our next question here. From Cloudy, speaking of versioning, are we expected to be proficient with versioning tools such as Git to pass the exam? No, you're not. No. It might be helpful if you're on a real life project and you're the security architect to just know at a high level what some of these versioning tools are. But for exam purposes, you just need to know what versioning is.
Yeah. And that's where we always talk about it being so dependent upon your career. For an architect, they need to know what Git tools are for. But they don't have to be familiar with them because they're never going to use them. It's not part of their job. For a cloud engineer or a DevOps engineer or a software developer, Git's going to be part of their life all the time. And they must have good skills. But this is a security exam, so they may tell you the name of Git, maybe, throughout this process, or a few other repositories, but its features, its benefits. Architecture is not about touching the tech, so definitely not. Claudia, I want to make sure we also answer the previous question you had earlier, right around, which was related to the advantages of a DMZ versus a proxy, and they're not actually related technology, and we use them for different purposes, so let's make sure we also get to that.
Yeah.
So what
are the advantages of using DMZs instead of proxies?
I'm actually going to map this out because it's actually I think it's going to be something that's going to be helpful. And that's why I wanted to make sure we didn't lose it. So in this particular example, let's talk about the difference of where I would use a proxy server. So let's say this is my data center. Well, let's just say it's my campus. It doesn't matter. And in my campus, I had, say, 10,000 users. Normally what we do is we have a firewall which connects them to and we have a firewall over here, is we have the users themselves. Let's say here's a user. The user leaves the network. It goes to their firewall. The user's NATed out. The return traffic comes back and it's delivered to the user. This is the way we normally do internet traffic. In 90% of cases today, normal user, this is a NATed going out to the internet. Now there are cases where we would use something called a a forward proxy. And a forward proxy can be applied for security, but it's not going to be applied the way you are actually looking at it. So let's say this is a forward proxy. And what I can do here is I can have my users over here. My user, when they want to access something, they can go to the proxy server. The proxy server will go out to the internet. It will return back. The proxy server's traffic will go through the firewall into the proxy server, and the proxy server will return it to the user. And why did we do this in this organization? For a couple of reasons. This user is no longer able to actually go to the internet. Now, in today's world with next generation firewalls, in most cases, that's not a big deal. We used to use these forward proxies a long time ago because let's imagine that this connection we had to the internet was 1.5 megs. And if this was 1.5 megs, and we had a lot of and that was, a couple $1,000 a month, and we had users that wanted to go to the internet. Now the problem was half of the users that we had all wanted the same internet traffic. So we used the proxy in those days because the proxy would go out to the internet for a request. It would come back, the proxy would cache it, and then the next time we had another user that requested the same information, it would hit the proxy server and the proxy server would respond. So it saved on network bandwidth. That's typically where we use proxy servers. Now, the other place where an organization would use a proxy server, so let's say this is a country. And there's countries in the Middle East that actually do this. If the whole country had something that it didn't like, that it found to be patently offensive or illicit content for whatever purposes, cultural reasons, legal reasons, I don't know, whatever. But every environment has something they like or don't like, and whatever. So let's just say this is banned content. What can happen is the country can redirect every user when they want to go to the internet, and the user starts out here. The user hits the proxy server. The user tries to request something that's banned, and the proxy server sends a message back, denied, 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 denied. And that's why certain parts of the world use proxy servers. Now, that is all related to outbound internet traffic. Now, in this particular place, here's where we use the ZMZ. This is our protected internal network. We don't want anything getting into our internal network. But we might still want to have a website. And if we were to keep this website in our internal network, what would have to happen is we would actually have to allow traffic from the internet into our internal network, which would be a no-no, because then we could be attacked through the internal network. So what we typically do is, let's say we've got the internet that's over here. We have our firewall, which is blocking any traffic from the internal network coming here. So we've got, this is our firewall. And then off of the firewall, we create one new subnet that's completely outside of our organization. And this would be, say, the web DMZ. And inside of our web DMZ, we would have one IP address, generally speaking. And this would be the public IP address of the load balancer for our web servers. And the only thing that would typically be allowed from the internet through this firewall into the web DMZ is either going to be port 80 or port 443, and nothing else. And what kind of traffic is going to be allowed into the internal network? Zero, nothing. So that's typically why we're using a DMZ. So you kind of had two completely unrelated technologies, but I thought it was such a good question that I thought maybe we would just explain the use of both technologies and it might be helpful.
All right. I hope you guys enjoyed that little DMZ versus proxy lesson. All right, Cloudy, they're wondering, is there a difference between traditional configuration management tools such as Puppet, as well as Microsoft's configuration management tool, and infrastructure as, now I'm blanking, infrastructure as a...
It's code.
Code, thank you. Tools such as Terraform. Cloudy, there definitely is a big difference between both of them. Now, I will start off with this, is you generally want to use both in conjunction to each other. So for example, if you're going to use some type of configuration management tool, these are going to be things that you're going to be using to manage software and, let's say, different settings on pre-existing machines. And then your infrastructure as code tools, these are generally going to be something like a Terraform, if you want to think about, and this is going to be where you can build and manage infrastructure itself by just using simple code that you can almost, it looks like something that you would be speaking. But in general, when it comes to an automated environment, you will be using both to make sure that you have a proper automation system in place. All right, let us take a look at the next question here. And this is from Mario. They're wondering, is it true that carrier-grade network address translation is a layer of security? Mario, carrier-grade NAT is just a little bit different than traditional NAT. And basically what we're talking about here is that it's another way for a service provider. This is actually a very prominent type of solution when it comes to mobile networking. And all we're doing basically is we're translating many internal IPv4 addresses into another public IPv4 address. It's going to serve the same purpose here The side effect is that you're basically masking or obfuscating the original addresses. And that in turn can give you some, I use this term loosely, privacy. So I don't mean privacy in the sense of like confidential with security, but privacy in the sense that they can't necessarily see your IP address. And at the same time, what this helps with is that it makes sure that these incoming, basically traffic, these unsolicited traffic is minimized as well. So you can say, just like with network address translation, the idea of the side effect of security and then its original purpose to address scarcity kind of complement each other. But definitely, it is not a security mechanism by design. Let's put it that way. Okay, and let's take one more question from Ivan, and then we'll move on to the content again. So the question from Ivan is the DMZ in front or behind the firewall? Ivan, a demilitarized zone is exactly descriptive at the end. It's a zone. So what you want to think of it, that it's another network that is created off the actual firewall. So generally, the way that you can visualize this, if you look at a firewall and it has these different ports, you can take the port, and we say you can virtually segment it to be responsible for a different area of your network. The reason we call it a demilitarized zone is that in traditional, this perimeter type of security that we're dealing with is that we view anything that is outside of our network as untrusted, and then anything inside we view as trusted. The demilitarized zone is basically in between untrusted and trusted. So it's a semi-trusted zone that is still within our control. So generally, it's going to be an offshoot that's going to be hanging off of one of the interfaces or multiple interfaces from your firewall. And I believe that is it. Let me put it this way, guys. I'm going to share with you all a little link. This is going to give you guys a little additional reading material. This kind of ties into securing software as well as the software development cycle. This is a particular document that was, or a set of different documents, including some actual standards that were written by NIST as well. So this has to do with the secure software development framework. So again, if you wanted to get really geeky, and I'm going to say this cautiously, you will not have to know as much as is outlined in these documents for the CCSP. This is simply like if you need to satisfy the thirst of the nerd inside of you or the geek, you're welcome to read that. Definitely might be some fun reading, perhaps even before bedtime if you need a little juice of adenosine in that. But aside from that, if you enjoy so far the content, make sure you like the video, as Mike said earlier. And if you can give me a hashtag, and let's do something a little bit different. Let's do CCSP security.
Yeah, I like that.
Let's do a little bit something different. Let's spell out the security aspect of it. Yeah, I'll be first to go.
All right, so we're getting back to the content. I'm having fun. I hope you all are. And we're going to talk about cloud application assurance and validation. So I hope we've conveyed the need for security testing on the applications. And in order to figure out what we've got to do some threat modeling. So there's lots of methods to actually determine the threats that actually an organization faces, but we're going to talk about some common threat modeling approaches. We'll first talk about the concept of the STRIDE model, which actually came from Microsoft. And it came up with a standardized description of threats by attributes. So that way you could identify flaws and vulnerabilities fairly easily. And it talked about, it would look at the types of risks that existed. Could it be spoofed? Meaning, could the user hide their address and pretend to be someone else? Could it be tampered with? So, could unauthorized modifications be made to the application, for example, to the systems in some way, shape, or form? From a repudiation perspective, if a user did something, could they deny their actions after the fact, which again would be a problem? Yes, I wired this money, but there's no proof that I actually did it. So things like that. With regards to information disclosure, does the application in itself have in it sensitive data, and can it reveal sensitive data? Can the application be shut down, for example? So can it be DDoSed and shut down to the denial of service attack? Can somebody escalate privileges and go from a user level of access to a, to a privileged executive or administrator type access? Now, there's an older model, in case you may hear it, and potentially you could see it on an exam, just because they like these things. Some of these exams get academic from time to time. And there's a model that's been largely abandoned. Again, this also came from Microsoft, and it was called the DREAD model. So it looked at, when it modeled threats, the damage related to the severity of the attack, the reproducibility, how easy would the attack be to reproduce it or cause it to occur again, how easily, the exploitability of the attack, how easily could you exploit a vulnerability with this type of attack? And then it would look at the number of affected users and how many users could be affected by the attack. It would look at the discoverability, so how easy would it be for you to find the means to attack the system? And it came with a scoring system from 1 to 10, 1 being low risk, 10 being high risk. Another threat modeling method is the architecture, threats, attack surfaces, and mitigations approach. And here, when threats are evaluated, the first thing that happens, we have to look and understand the actual architecture that we're dealing with. Then after looking at the architecture, we look at all the threats that are available. We list the threats that we could have, the goals, how you would use these attacks, attack these threats, the methods that you would use, the objectives that you might have, and how you could attack them. You would look at the attack surfaces that you have. You would look at the security controls that you have and mitigate any remaining attack surfaces that you identify that you can. And you would implement some good, strong form of defense in depth to make sure that you couldn't attack things. Now, I miss eating pasta. I used to eat grains until I went paleo diet, but my family's Greek, so I ate a lot of pasta. So the next method is the pasta method. And they came up with pasta because it was the process for attack simulation and threat analysis. And boy, do I love pasta. And there were basically 7 stages of this modeling method. And the first stage of the pasta method was to determine the business objectives. And the next phase would be to look at the technical scope of the assets and components that would be used. And then the next phase would be identifying any kind of application control that would exist. And from there, we would perform a threat analysis based on whatever threat intelligence information we had. We would then detect any vulnerabilities that we could find and analyze and model various attacks. And then we would perform a risk impact assessment and develop the appropriate countermeasures. So we talked about a couple models. We talked about the STRIDE model, which was more about identifying potential threats during the software development lifecycle. We talked about the DREAD model, which was from Microsoft, but it's been largely abandoned. We talked about the ATASM model, which focuses more on architecture and attack services. And we talked about the PASTA model, which is more about simulating and analyzing attack results. So let's talk about common threats to applications. So one such threat is a user, a malicious user, can inject code or a string of fields into the application. And if they do things or input the wrong thing, well, then potentially the application could give the raw data or unauthorized data. Examples here would be SQL, LDAP, OS-type injections. So we can have some data exposure or consequences there. One type of an attack that can occur. Another type of attack with regards to our application is somebody can authenticate. They can authenticate as a legitimate user and then escalate their privileges to that of someone who has access to more than they have, like a systems administrator. And here what they're exploiting is some weakness in the authentication systems. The next thing that I'm thinking about is threats to applications themselves, like cross-scripting attacks. So what if we have untrusted data in a web browser sent in, and it puts something that causes some that affects the application. In one of those forms on a web thing, for example, we put malicious code, and somehow the server allows that malicious code to actually work. This is obviously not a good thing, right? So we want to make sure that we have some form of input validations or something that protects a user from putting in bad code. The next thing we can talk about is insecure direct object access. And that's one of the reasons we wrote this book, to go along with this for you. Because there are points in this program where I apologize, it just gets dry and academic, and this is more one of those places. So in this case, an attacker is going to reference an internal object, but they're not going to have access control to it. So here, typically speaking, they're going to lack the control to hopefully manipulate data, hopefully. But if you've got an attacker that can reference internal things and lacks control to manipulate things internally, can they get access to these things internally? So we also have the concept of various security misconfigurations, and we talked about this earlier. I think Kennedy asked the question. You will find more security misconfigurations in most organizations if you actually were to go and look. You will find all these holes and backdoors that are purely the result of just basic human error. And I can tell you why this happens after interviewing thousands of people. I can tell you, I see it every day. So many people are focused on let me build, let me build, let me build. And they're so busy with hands-on projects that they don't take the time to learn the fundamentals or learn how the technology works. If you only know how to build, but you don't know what you're building or why you're building, that's where the problems occur. And we see this all the time. Common threats to applications. Another common threat that we're dealing with is sensitive data exposure. So we've got an electronic health record in a hospital, and somehow someone breaks into it, and they find the patient's private health information, their medical data, their insurance card, their credit cards, their check account number. And this is obviously something pretty serious. Now, ideally, the organization would have had in the proper security controls, encryption, data masking, tokenization, what have you. But if they didn't, these kind of things happen. Missing access control. That's something you're going to see all the time, where basically speaking, you've got an application and it fails to identify your privileges every single time. Malicious users, you can see it to fail request. I'm sure you've seen this. You've got a website you log into all the time. Sometimes it sends you your two-factor authentication. Sometimes you just slip through. Sometimes it sends you to a CAPTCHA page. Sometimes nothing happens. Lots of funny business like that. Sometimes they don't do the things they're supposed to all the time. We also want to talk about a cross-site request forgery attack. And what's going on there is there's a manipulation of a user's login data, and it sends these forged HTTP requests. So basically, the victim's browser is sending requests that are appearing legitimate, but the requests are actually vulnerable to attack. So let's talk about using components with known vulnerabilities. I promise you, in real world, we're going to use things that have vulnerabilities in them. Developers will actually use code that has a vulnerability in it and either not think about it, not read it, or not understand what its implication is in the overall architecture. And how can you expect a person who's focused on writing code to be thinking of, literally speaking, everything? So we need to have good quality assurance and testing techniques and testing processes. So that means a combination of automated testing and manual validation testing, because automated anything will make mistakes and manual anything will also make mistakes. So if we combine the two, we get better results. We want to make sure that the software is tested in so many ways to make sure it meets the standards or requirements. It's going to involve reviewing the software, testing the software, reporting the software, and many other activities. QA staff should be responsible for functional testing and non-functional testing. Developers need to be available for code reviews and user testing. We need to have good, strong end-user acceptance and functional testing of any applications that are deployed. When we talk about functional testing, We want to make sure we use lots of different methods, either something called integration testing, which is going to validate various component interactions. Regression testing, which is we've got a new version. We check for reintroduced bugs. User acceptance testing, where users actually test it and they use it in a real-world environment and they make sure that it actually works. We want to make sure we do non-functional testing too, and non-functional testing is testing the quality of the software. So how does it feel to the how does it feel? What are the attributes of it? We want to load test the software, which is put it under load. Stress test the software, which is where you put it under more users than you think you're going to get and see what happens. Along the way, we should be actually testing the code itself. And how can we test the code itself? With static application testing, where there's basically reviews on source code. So this is going to require someone that's going to test this to be able to look at the code, read it, understand it. AI tools can do a whole lot right now at reading and testing code for you. But by doing this and by checking it potentially with AI and then manually thereafter, you can make sure that your code behaves and works the way it's supposed to. Now that the static testing is looking at the code. There's also going to be dynamic application testing that's going to need to occur, which is testing code or running applications. It may involve some automated processes or manual processes. An automated process could be to spin up 10,000 users on the cloud to try to access this application pretty quickly from multiple virtual machines. I mean, somebody's writing that automation script, but the infrastructure as code is fairly automated there. But we might want to validate the source code, test, real-life performance, those types of things. Another type of methodology for testing software is something called interactive application testing. And here we're going to analyze the code for vulnerabilities while it's being used. This is going to give us some real-time reporting. We may integrate it into a CI/CD process for automated testing when we're testing releases. We can analyze internal functions while the application is actually running. Another type of testing we could use for our software is software composition analysis. And here what's going on is we're looking at the different software packages or applications that are used as part of the entire application. So if we have an open source environment and we have one type of software that requires 10 other pieces of software to be installed there, what happens when one of these packages has a known vulnerability in it? So by using a software composition analysis, we can look at, okay, this software requires this library, and this library, and what are the vulnerabilities in these common libraries? So let's talk about white box testing and black box testing. So we may test the software this way. In a white box environment, we give the tester all access and all knowledge of our systems, all knowledge of our code, and all knowledge of our environment. So they can recreate the environment and they can test it in our exact environment. To be used for static testing, used the entire way along. Full testing knowledge. We can also do what's called black box testing, which is where we say, here, test this. You don't know anything about our information. We're not telling you. That's why it's called black box. And you simulate an external attacker's perspective and see if you can break into it. That gives us something too. Because the people that know how to break into our systems, that know all the information, will have the easiest advantage in breaking in. But we also may want to find out how hard it is to actually break into our systems if you don't have that information too. Find out how vulnerable your software really is. You also want to do some abuse case testing. And abuse testing is where you almost simulate a denial of service attack on the application. I'm exaggerating it to a degree. But you test it under extreme situations. High processor load on the server, low memory in the server, ridiculous number of requests. And what you're trying to see is, does the software behave in an unfamiliar or an erratic way when it actually is under this kind of heavy-duty load? Because this will show you a different kind of weakness or coding flaw, and that can find some good security vulnerabilities or features or functionality challenges that need to be controlled. Okay, so we're now going to talk about third-party software management. So a significant portion of an organization's software, in most cases, is going to be provided by third parties. And it's going to be very essential to manage the software supply chain and all these third-party softwares. So when I talk about 200 to 1,000 different applications in a business, and I say that the cloud certifications that are teaching you things like the solutions architect that only show you a single vendor environment are a little not reality, I want you to think about an environment where there might be 500 software packages and 100 different vendors, because this is where we are as architects. And when we're dealing with this, there's licensing issues. And we need to make sure when these licenses are coming up that the vendors are able to provide software and updates at a pattern that's going to work for our organization. We're going to have to consider the organization's reputation, their normal response times, their remediation capabilities if and when something were to occur. We're going to be looking at that vendor's long-term stability and business practices. Are they known to be ethical? Do they support their clients? Are they financially stable? Or are we going to spend all this money investing in this ecosystem, train our people, and then the company's going to be out of business very shortly? And we need to understand our primary vendor dependencies, including open source tools and closed tools. So we need to understand, not us necessarily as security people, but us as in some architect somewhere in a company needs to understand the types of software licenses that are used inside of the organization. And somebody on that team, not necessarily the architect, will be thinking about maintaining the licensing and the license quantities, but somebody's going to have to manage that. And somebody's going to have to make sure that an organization is complying with the appropriate software policies that are based upon their software licenses they have. And from a risk management perspective, we always have to validate any software we have in the supply chain. Where is the software coming from? What relationships do we have with what vendors? So do we have license compliance? If not, are we going to get fined because we did something we didn't know we were doing with the software license? That covers a lot of those things. So the next section, Mark, how long has it been? Because we're going to get into identity and access management next. Where's my... All right, I think it's been about 20 minutes. Let's take a quick break here, answer some questions, and then we'll get into identity and access management.
All right. Let's tackle the question from Scooby that just came in first. And then I just wanted to address some additional reading material. I'm going to call these goodies for everyone in case you wanted to go a little bit further into threat modeling. But Scooby is asking, the high-level view of the CCSP exam won't touch on AI, will it? No. As of the latest exam objectives, AI is not mentioned, really. There's going to be, and you generally should make assumptions, but there's this notion that goes across the community that with a revision of the exam, we don't know when that's going to happen. There's definitely going to be some input in regards to AI, at least some basics when it comes to that. What you have to remember about AI, that it's, while the foundation of artificial intelligence can go back 30, 40 years, if not more, we are at a moment in time where we're still trying to figure out a lot of proper use cases for artificial intelligence. We're just hoping that we're not going to go down the route that a lot of architects as well as engineers did with the cloud, where we're going to make up use cases that eventually are going to cause more detriment to an organization compared to actually having some added value to them. So for the moment, though, you don't have to worry about it. But I want to caution everybody, when you take IC Square exams, they do liberally put in questions to see how they're going to be received. So there could be questions that come up that are not necessarily covered on the exam itself when you look at the objective. Just know if you get something like that, then most likely it's not counted, and it's just something for them to kind of understand where people are at with their level at the examination and also to test out different formats of how these questions are going to be posed to you. But aside from that, yeah. Go ahead, Mike.
But I would say we did cover a little bit about deep learning and machine learning. That is AI. So it's not an AI-focused exam, but any of the AI topics that we covered initially, I would consider them to be in scope, which is not a whole heck of a lot. Well, we spent 30 minutes on it, so it's not going to go deep on AI.
Correct. And for those that are interested, and I hope you'll forgive my clicking here for a moment, but as architects, you will be involved, and while it wasn't necessarily mentioned too much in the CCSP exam, definitely as a security architects, you will have to do a level of threat modeling. I am going to provide you with resources. One of them is going to be from NIST. This is going to be more of, again, a framework, a guideline on how you can use threat modeling. I'm also going to provide you all with the link towards MITRE. MITRE is a very popular platform out there in regards to its structure and framework in regards to general security threat modeling. And then I'm also going to provide you the threat model that comes from the, I always forget what they stand for, OWASPs. I'm terrible sometimes with acronyms, but OWASP is also an open source, open kind of standard society. And they also have a project that deals specifically with web application threat modeling. So I'll definitely provide you all with that. In the meantime, if any of you have any further questions, just let us know. And let me first of all do this. So this is going to be the NIST 800-154. This particular link that you'll see in the chat below, so I'm sorry you're not going to see that actually on the, well, unless, Chris, are we able to put my comment up on the screen as well to have it in the video? Is that a possibility? The last one? Fantastic. So for those that are actually viewing the video, let's say you're not paying attention to the chat, that is the link. This is going to deal with data-centric systems, threat modeling from this directly. Now with MITRE, and I'm going to put this as well in the chat. So MITRE is the company, and the model is actually called, people pronounce it ATTACK, but it's really ATTCK. So what is really interesting, and Chris, if you want to put that link as well up on the screen, please. What's really interesting about the MITRE model is that you can actually click on the different links within that model, and it's going to propose mitigations to the particular threat surface that you're going to go through. So this is really great and really robust if you don't already have a threat model in place to work off of. And when it comes to OWASPs, and let me add that to the chat as well. So this is going to be OWASP Threat Modeling Project. And that as well is in the chat. Chris, if you mind putting that up. So this particular OWASP Threat Modeling Project, as it says on the page, has to do with modeling techniques for applications of all types. So again, this is a little bit more specific towards the applications, very much what we've been discussing within our bootcamp so far. The other two, general security, that's where you're going to come into. And just to kind of round up the proper additional reading, here is a little what OWASP calls their threat modeling cheat sheet. And that is something as well that you can review, take a look at it. It's going to be a little bit more involved, but I think it's still going to be a fantastic resource for everybody to look through. Again, do you need to know all of these in detail for the exam? No, but I wanted to give you all a little bit additional value, especially as you proceed in your security career, that you can look through these things that are going to be more conducive to that planning and design aspect that you as architects will be doing. Yeah. Aside from that, I hope you all enjoy that. If you do, give me a hashtag CCSP. Let me know that's your little thank you for these additional resources. And I know the content sometimes can seem a little bit disconnected from each other, but I hope this kind of brings things home a little bit. Aside from that, Mike, do you have anything to add before I send it back over to you in regards to continuing the content?
No, I really like those resources you shared, and for everybody that's there, look where he gave you information from. These are from the organizations themselves. They're from the government, and typically what we're actually referring to here is going straight to the source. So when you're ever in doubt, we like to go to the source.
And the nice thing about all of them is that they're not specific to a vendor. So these are things that you can take. You can choose to apply bits and pieces of it. That's the beauty of framework. And the other things is just, let's say you don't have something and you want to get an idea how threat modeling is put in place. Again, these are industry known resources. So you don't have to worry about that there was some bias put into it by a particular vendor because there was some type of financial gain to get to following these particular practices. And Scooby, you're 100% correct. Just because the bootcamp is free, it did cost us a lot of time and money to put it together. And we try to do our very best to give you as much value as possible when you're spending your precious time. And some of you even took a little time off work to be here. So this is our way of giving a little bit extra back to the community. All right. It looks like everybody's awake too. And you're very welcome, Sia. You're very welcome. All right, Mike, I'll hand it back over to you. And we can take a look at identity access management.
Absolutely, identity and access management. So let's really talk about what it is. I don't know why, but they make this sound so complicated, identity and access management. It's very, very simple. Who are you? Because I need to know. What are you allowed to do? And then what did you do? So, before we get to this, I had an idea. So, I see a lot of people are asking some questions in the chat box. And there's a lot of career questions. So, I promised you that I would create a session where you could talk to me and maybe you could talk to Mark or another executive from my team and ask us career questions in case your goals weren't just architecture. Like maybe you wanted an engineering career or a network career or a defensive security engineering career, or you just want to know about moving up in your architecture career. How do you go from a $150,000 architect, for example, to a $500,000 a year architect? Or how do you plan your futures? So on Wednesday night, I'm going to create a free career session on Zoom. And that way we can actually talk about things and answer some of the questions that are popping up. I'll review your LinkedIn profile if you want, if that comes up, for example. We can do a limited number, not all of them, but maybe one or two. We can look for things that highlight certain things. You can ask us questions. We can assess your readiness. So we'll do that free on Wednesday night, right after this is over. And my team will set up a link for that because I think that might be helpful for some of you. And then the next thing that I will say is on Thursday, we're going to really go over the how to become an architect. We'll talk about what we do, the skills of an architect, what employers are actually begging for, how do you skip HR and their auto rejections and be seen by the hiring manager. And that's also going to be free too. So that'll be 2 opportunities for us to ask us career questions this week. For architecture careers, come to the Thursday one, but you're more than welcome on Wednesday. But for other careers, please join Mark and I, or me and someone from my team on Wednesday night. Right after this, maybe from 5:30 to 7:30 or 6 to 8. Chris from my team will set up a time, but we'll do that Wednesday night if anybody wants, because I knew you guys asked for it last week. So now let's go back into identity and access management. So in this particular case, it's about identifying who you are, or who you claim to be, determining what you're allowed to do, and then keeping track of it. So the authentication is, are you who you claim to be? So 3 days ago, this little gray cat looked a whole lot like Cindy, was actually at my back door, stared in the door, and I looked at that cat and I went to open the door because I thought it was my cat Cindy. And then I recognized this gray circle on that cat's chest. It's a beautiful cat, but my cat Cindy does not like that cat, so I kept the door locked. Because I don't want my cat Cindy and this cat fighting. I'm sure they're both wonderful cats, but Cindy and that cat just whatever. But that cat comes to eat at my house every day to go play with my cat, and my cat doesn't like it. So, oh well, it is what it is. So, have to authenticate that person. Now, when Cindy comes at the back door and she looks at me, and I look at her and I see her, I know she's her, and I open the door. At the same time, If a friend comes over to the house and I look and I see what they look like and I know it's them, I open the door. I've authenticated them. So that's authentication. Who are you and who do you claim to be? Now, authorization is determining what you're allowed to do. So we'll go back to my cat, Cindy. Have any of you ever had a cat and tried to close the door to your house? And you notice the first thing you hear is eek, 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 because they're not happy. And the next thing they do is they dig up the carpet by that door because they want to walk in the door because they want to get in. So I have learned that I have no permissions for my cat. She roams from room to room in my house. But let's pretend I didn't want her to walk into a certain room. I could close that door, for example. In order to get to the door, I could have her, I could have her have to get permissions. So maybe she could enter a code with her paw that says privilege escalation, open the door. But the point is I need to determine what that person's allowed to do. So I have my users. I have a database of each user and what they're allowed to do. And that's the point of authorization, keeping track of it. So I log into the system. I'm an administrator of the system. I can do anything I want. Now, a buddy of mine, my friend Mitch, comes over to my house. He's not exactly Mr. Computer by any stretch of the imagination. He can still use my computer, but he can't break anything because he doesn't have administrator privileges on my computer. Same thing that we're talking about, authorization. Giving people access to what they need when they need it, and only what they need to do their job. And then accounting is keeping track of all the things that you've done. So you installed the patch to the operating system. I kept track. I saw it. You installed a new application. I saw it. So I know what you did. You accessed this resource and downloaded something. I know what you did. So we're going to briefly talk about the concept of identity and access management federation, because almost everything we're going to do in some way, shape, or form with cloud computing is going to be federation. And what am I mean by this? So let's say an organization has a data center. And they are an enterprise. They have 100,000 employees. All these employees have been in Microsoft Active Directory for the last 20 years in some way, shape, or form. That's their directory service that maintains all their users. And then they have a new name for it in the cloud, but Active Directory, the data center standard. Now, all of a sudden, I'm in the AWS cloud. I could, conceivably, if I was silly, pay people to create 100,000 users inside of AWS and use the AWS IAM. I could do the same thing in Azure. I could do the same thing in Google. I could do that. But why would I? Because that organization already has Microsoft Active Directory that's authenticating everybody in that enterprise. So what I could then do is I could create what's called federated identities. So every time I have my Microsoft Active Directory. Let's pretend I'm in AWS. I take the AWS identity platform and I say, you are integrating into my Microsoft Active Directory. And then what happens is when a user comes in and they want to log in, they try to log into the system, say on AWS, their authentication request is sent back to their Microsoft Active Directory server. The Microsoft Active Directory server says, I got you covered. And it sends the authentication request back to AWS and you're allowed in. Could do the same thing with Azure and Google. That's federated identity and access management, and you're going to see that all the time. But where else might we do with federations? Have you ever logged into a website and it says log in with Google? Or log in with your Apple ID? Or logged in via your LinkedIn account? That's also federated identity and access management. So some organizations will connect to an identity provider like Google, like Amazon, like some of the others that I've previously mentioned, and they will use them as a source of information. And that's why you can log into various accounts through your Gmail account, because they're pulling your authentication information from Google, which is an identity provider. So when we deal with federations, we basically have identity providers or identity repositories, which are systems that house all these identities. And that's what federated is. We tie ours into something else. Now, when it comes to identity and access management, the accounting is tracking what the user did. So why do I need to know this? Well, Mark comes over to my house, and believe me, Mark's more hands-on with networking these days than I am. And Mark, I asked him to go tune up my network. And because, I want to upgrade my 1 gig. I mean, I've only got some of my rooms wired 10 gig. And, we need to go fix this. And so maybe I would put in a new network inside of my house. And we're upgrading the network. We're tuning the routing. And all of a sudden something broke. Well, if I can see the list of things that Mark did, I know back which ones to fix if it breaks. Of course, he would have tested it before it left. But you get the concept and you get the point. Now, in that case, we're using it to go fix the mistakes that we made. But what happens when I've got a hacker? I want to know who did what and what they did and why they did it. And maybe it's a person that just made a meaningless mistake, but it was a security violation, and I want to be addressed that with them and train them for the future. That happens all the time. A lot of mistakes are unintentional. But maybe I've got someone creating an vulnerability or backdoor intentionally, and I want to be able to track that too. One thing that we can say is in the cloud, we're going to be using a lot of identity and a lot of access control. And also understand in the data center, we have much more micro-segmentation and separation than we can do in the cloud. Much more. And in the data center, if we were a little sloppy with our identity and access management, which we shouldn't have been, but you had to be on the system, and in most cases that meant in the same building. Or through a VPN, which went through a series of stages to be secured and locked down. We knew where you were coming from, and we can segment you off. In the cloud, it's all one big giant shared data center, so there's a lot less of this. So there's a concept of identity and access management, authenticating you with every major step that you do becomes more important. And whether we're dealing with infrastructure as a service, which is pure virtual data center, like virtual machines and containers, or platform as a service, which is more application virtualization, or software as a service, where we're dealing with, say, Microsoft Office 365. It's the same kind of concept. We've got to use a lot of identity there. In some cases, that's most of what we can do. So we could potentially use a cloud provider systems for authentication of our environment. We could. And they typically one thing we typically will do is maintain a top-level native account for configuration and maintenance for our cloud environments. And then we typically provide fine-grained access controls for everybody that uses our system. So never giving more than people actually need to do their job. That's something that's pretty important, which we need to talk to about at all times. And we have to be able to manage our secrets, our keys, our certificates, our credentials, and secure them in a very secure environment. Because if we lose a lot of these boundaries, and what's protecting us is an encryption key, or a secret, or an identity, and that gets compromised, we just lost everything because we have much less controls in place. Or we can lose so many more things. Let's talk about privileged access. So, the privileged access accounts, or the people that have super user, or root, or administrator type privileges, they need to be locked down the most. If you get Cindy the cat's identity and access management plan, it's pretty easy. She's authenticated by Paul, and what's she allowed to do? She's allowed to go to YouTube and look at videos of, say, fishes and seafood swimming around, and watch squirrel videos, things that would make my cat happy. But I don't want my cat getting in trouble. I don't want her using my credit card and ordering things, because, my cat would try to do that. She'd be ordering exotic lobster from Maine every single day. So, we want to control the access of what that user can do. My cat walks on my keyboard. So think about if she walked on my keyboard, what she could actually delete. So when we have an administrator account, not only do we need to trust the person, but we need to really lock down who can access it and lock down those credentials. So that person that can cause damage definitely needs to have more than one-factor authentication, or should. We need to be doing logging and alerting when they do things. We need to be watching the behavior of our super user with behavioral detection systems, because when super user goes a little too wacko, we've got a problem. And we've got to be able to periodically audit every time privileged access gets there. Now, when we're dealing with, it doesn't matter whether we're dealing with traditional environment or microservices. We need to control every weak request whenever possible. And as we move forward towards zero trust frameworks, verify this request, this request, this request, this request, this request, to make sure that you're constantly being supervised in what you're allowed to do. So we need to get pretty stringent specifically in the cloud. And we've got to be very good and careful about where we store these credentials. Let's talk a little bit about single sign-on and its strengths and its weaknesses, because nothing is free. Everything we do to tune and optimize helps us in one way, and it hurts us in a completely different way. So I do want you to think about this. Here's what single sign-on is versus traditional sign-on. In traditional sign-on, I log in once to get access to the system. Now I log into the company webpage with one password. Now from the company webpage, the internal website, I now go to another system. I log in with a different username and password. I go to the next system. I have another login, different username and password. Now, this gives us some advantages. If you compromise any one account, you've only hit that one account, not all of them. So there is that. But if you're in an environment where your user logs into 80 different applications per day and they can't remember their 80 different passwords, the next thing they're going to do is they're going to have a little book on their desk that has passwords in it. And it's going to say passwords on the book. And, all you got to do is steal their password book. I've seen it. So single sign-on is I sign on once. I've proved who I am. When I want to go to another system, there's a token request and a token sent, and I go through and I through because I logged in once. So much better experience for the users. A lot less time logging into various systems. The benefit is user convenience. The risk is now you've got more systems that can be compromised if you get access to one level. So there's that as well. Now, you can also deal with cloud identity providers as well, and they all work with identity providers. So they're all dealing with your Google, your Facebook, your LinkedIn, or your big Gmail kind of providers. So the cloud providers can talk about that. And I talked about federated identity management, and that makes it even easier to do things like single sign-on. So when we're dealing with any kind of identity management, we're talking about a trust model. So if this is the primary receiver, any of the users that connect information from the receiver have to trust it. So they say somebody is the chief, everybody else trusts the chief, they're good to go. That's your typical federated environment. So it can get costly, it can get complex with there's many members. And there's two ways that it can typically be done. It can be done via the trust model. And you might use federated identity and access management if you've got two companies and they do a lot of business with each other, or they merge with each other, for example. And you've got one company A who's got their directory systems and company B has theirs. They each set up a trust environment between them. And then the users in the acquiring company can access systems in the acquired and vice versa. So that would be a reason we might use a federated trust model. Or we might have 3 hospitals and an integrated healthcare delivery system, and you can log in and get access to, if the doctor goes from hospital 1 to hospital 2, potentially they could log in using their credentials. So that might be the reasons you might use the federated identity management trust model. By comparison, the third-party model is more when you go in there and you federate with Google or Facebook or LinkedIn. They're all federated identity, but you might use them for different models. In any cases, when we're dealing with federated identity management, there's some key things in terms you need to know about. So we have the identity provider. The identity provider is when you've got a user, you've got a company, and they are the providers of the identity. So they're managing the user's ID, managing user provisioning, managing user passwords, identity lifecycle. They manage all of it. And then the people that use that, they're members of this federation, and they will basically take the information and handle it according to their own policies. It all works on this concept of trust. So if I have 100 entities that I trust, and Mark, by comparison, has 100 entities that he trusts, then our users that he trusts in his systems, then we connect to each other, all 200 systems can access it. That is that web of trust. I want to go back to it again. Third party is I deal with a LinkedIn or a Facebook or a Google. So I might have less trust in the information I'm getting from that third party, that identity provider, than I might get from up here. So we're going to get into the concept of multi-factor authentication. It's not a new thing. It's a very old thing. And basically it's based on something you have and something you know or something you are. So when I was a kid, about 40 years ago, they came out with an ATM card. I remember it. Maybe I was 12, 13 years old. I was a young man at the time. And all of a sudden there was a card that you had. And you would take it to a bank and it had this machine and you'd push a couple of numbers and you'd be able to pull money out. I thought that was like the coolest thing. And it used multi-factor authentication. It had a card, which is something you have, and it needed a PIN number, which was something you knew. So that's how old two-factor authentication is. And they've used other forms of a part of that. But there was the first one that I got to work with because I was a kid. Now we've got something you have, which could be a key fob. An RSA security that's coming up with things. It could be a token. It could be something where you log in and you get a text message. Something you have your phone, and then you receive that message. It can also be something you are. So, an iris scan. You put your eye up to the thing and it goes in there. It could be a fingerprint scan. I don't know. Maybe I can scan Cindy's paw prints for access to the computer. I've been thinking about it. I don't know. But so there's your options. Something you are, something you have, something you know. Now, we have to think about that it's not always practical to use biometric authentication. So something you know and have factors are pretty good. So in remote access where you can't provide your fingerprint, something you have like a secure token is pretty darn useful. And it's going to protect against unauthorized access by requesting both whatever you need, a password or a key. There's a way to get in, use a username, a password. Then it sends you something else that gives you another challenge. So there's more things. So it's becoming not only needed, but what you're finding is some companies, all of a sudden your bank tells you you have to use multi-factor authentication. Pretty much what happened in most cases is their insurance companies said, we're not going to insure you unless you have multi-factor authentication. So poof, that's why you're seeing it be there everywhere. So for cybersecurity, insurance is becoming more and more prevalent. So at this point, I mean, not that any security people are going to be designing any applications, but we need to make sure from a security perspective that our application team make applications that support multi-factor authentication. I talked a little bit about secrets management. Mark addressed it a little bit earlier today. I think there was a question related to it, but let's talk more about it. So we have to store our secrets somewhere. So usernames and passwords, we've got to put them somewhere. API tokens, license keys, database strings, certificates. Where do we put them? So lots of ways they can be stored. They can be put in a safe, inside of a vault, inside of something if you wanted to. They can put, a lot of the cloud providers have places to store your secrets that are managed environments. They can be put in a building that has a Faraday cage, which has a vault, which has a safe, which has a safe, which has a safe inside of that safe. They could be guarded by, I mean, depending upon what you're storing, you can determine whatever level of security you need, but make sure we share these things. So the cloud providers also have secrets tool. Amazon has Secrets Manager. Google has the Google Secret Manager. Azure has the Azure Key Vault. But there's lots of other options that you can choose from as well. So when we talk about secrets management, this should be part of the integrated into every component of the development practice. So it should be there. So there's a cheat sheet with regards to secrets management from OWASP. and they actually talk about what you could actually do, and it gives you a guide with best practices. Perhaps Mark can actually pop that in the chat box. I'm pretty sure he already did. So there's some common threats to identity and access management in the cloud. Understand that attackers are increasingly targeting cloud identities to access cloud-type environments. There's some pretty common IAM threats that you see consistently. Either people lose or have expired credentials. We see lots of improperly configured permissions where people have access to more rights than they actually need to do their job. That concept of excessive permissions all the time. I can tell you, when you actually look at an organization, they may not even know what's going on or who's monitoring their systems. It may take them months to find out that they've been hacked or systems haven't been used. In the cloud, misconfigurations are everywhere. I mean everything. And that's because the majority of certifications are, here's the name of something, here's how to configure it, but they don't teach what it works or the underlying technology. So what you find is you're creating a bunch of technicians that are trying to do engineering work, but they don't have the engineering knowledge. They don't have the fundamentals to do their job. So they're just hoping and begging they configure things correctly. And we see so many security holes because of this. The shortage of cloud people, the shortage of cloud architects, is just, for example, is just so critical. And there's almost nobody with the skills. So you see a lot of these things that are designed poorly. But these misconfigurations are going to be in the security. They're going to be in the network. They're going to be in the IAM policy. They're going to be in everything. And then the next thing we need to talk about is common threats with regards to identity and access management, which realistically speaking is keep these in the concept of your mind. Think about what we're really trying to deal with, who we are, what we're doing, why we're doing it, why we're keeping track of this, and why these systems need to be up to date. Okay, well, now we're going to start talking about more of these operational elements that are actually going to be going on here. But before we do that, maybe now's the time for a quick set of questions. And next set of questions.
All right, let's take a look, and I'll add some additional links for everybody in a little bit for some interesting additional reading. All right, let's take a look at our questions here. From Scooby Dow, can you commit to projecting your industry position for the long term as future reference in career profile? Scooby, I personally would need more clarification exactly on your question.
Yes.
Bit torn between, is this a career development kind of question, or are you referring to something a little bit different here?
Yeah, so please clarify it, because we want to make sure we're answering the right question.
Okay, let's take a look at Cloudy's question. They're wondering, is there an actual contrast between federated authentication and a pointing a system to an identity provider? Is there a second part to that too, Chris? Okay, so they're saying, for example, in a merger where both domains are kept up and federation is established between two domains for authentication and access purposes. Okay, so that's a second. Okay, so the actual question is there a contrast between federated authentication and an identity provider? So there is a difference between both of them. With federated authentication, what you want to keep in mind that it involves basically establishing trust, a trust relationship between two different type of organizations or say domains. And a good example, Mike already gave it, is when you think about like a merger, when two companies are trying to kind of retain the IT systems, and what they're doing is they have also their own identity providers, and they basically agree to allow one user from one domain to be able to access resources on the other domain. So this in general also is in conjunction with single sign-ons and also multi-factor authentication. The identity providers, I'm pointing it to it. To me, the way that I understand your question, and this is how I'm going to phrase my answer, has really to do more with configuring specifics to a system and the way you would be authenticating an actual user. While it is simpler. Sorry, Mike, go ahead.
I understand his question now. So finish the answer you had, and then based upon what he put, I think I know what he's asking.
Yeah. So for a single domain, having an identity provider is going to be a lot simplistic, easier for you to do, but there's a distinction between both of them. Go ahead, Mike.
Okay, so I'm the way you answered this question was perfect. So I don't want to step on that or answer that. Going back to Scooby Dow's question, where he asked a question that neither one of us understood. What he's referring to is, can he, if I understand the question correctly now, and I'm going to ask the question, Scooby, but I think I know your question because others have asked this. Can you put down on your resume or LinkedIn profile something that you'll be 5 years from now? No. That's like putting down an MBA when you're still in high school on your resume. No, you can't do that. You have to be now. You can become a security architect in a good year and be hired in around a year. And when you're ready to be hired, you're a security architect, and that gets confirmed when you get your first job. But no, you can't put a CCIE, an MBA, a PhD, or anything else that you don't have on your LinkedIn profile. That's fraud. And that will be met very quickly and punished heavily. I remember at one point, I had two people when I send their resume to me, and it had CCIE on it. And then when you look, they had this little CCIE and this little 10-point font it said written. When the person came in, I said, what's your CCIE number? And they said, I don't have one. I said, but you have in big bold letters on your name that it says CCIE. I passed the written. I said, so you took the test that allows you to take the test? Well, at that point, I fed him cookies for 15 minutes. The interview was over because he lied to me about who he was. So, you got to go out there, you got to be yourself, you got to be honest, and you've got to be trustworthy, because when it comes to any type of professional job, you're going to be working with billions of dollars of systems, or you're going to be working on technology that, literally speaking, if you make a mistake, could cost 30,000 people their jobs. You're going to be working with technology in a hospital where if you make a mistake, somebody's going to die, or an airplane's going to fall out of the sky. So we have to be open and honest about what we know. We have to be realistic about what we know. We need to be prepared at what we know. We need to be really good at what we do. And you can't commit to your future because some things are outside of your control. Now, you can have your goals, and you can build your plans, and you can achieve every last one of them, but you can't tell other people you've achieved them until you have. I hope that seems okay.
Yep. Wholeheartedly agree on that. From Cloudy, is Federation somewhat similar to provisioning? I will put it this way to you, Cloudy. They both deal with identity and access management. But instead of being similar to each other, I would say that it's a bit more complementary from that perspective. And this is how I view them, because when I think of Federation, and then you think also how Federation and provisioning is actually viewed on the exam, Federation for me is this seamless connectivity across two different organizations or domains where you're exchanging a level of trust through authentication. While provisioning is focusing more on how do you manage user accounts and their permissions in a specific system or an application. So it is more complementary. They work more together than being the same thing. Yeah. Let us know if that gives you a high level understanding of what this is. If we need to dig a little bit further in, I'm going to provide you all with some additional reference or additional reading material that if you wanted to dig into it a little bit further, you can. But I'll do that once you don't have to hear me clickety-clack here with a mouse and keyboard. But that definitely, I'll get you guys some additional resources. Before we move on, give us a hashtag CCSP Let me know as well if you want some additional reading material. Again, it's a little overkill for the exam, but for your career, I think this is going to be a fantastic addition to your overall security portfolio that you can put together with your notes and reference materials and so forth.
So before we get back to things, I'm going to have Chris drop a link to the free question and answer session we'll do tomorrow night. And that way we can actually answer some real questions, ask you questions, get your feedback, because sometimes it's a little hard in the chat box, but we should be able to take you. So you know, and I'm going to answer Scooby's question, and then we'll get back to it, and we're going to talk about honor code and certain things, for example. So to get CCSP certified, you don't need me. You know, we give you the training 5 years from now, you'll be good if you pass the test. You don't need anybody here that's along the way. I could be dead 5 years from now. I mean, I don't plan on it, but, you know, there is that. But I plan on doing everything I can, continue to do what I love, which is train the next generation of technology people. But I do give a lot of references, Scooby. I give them all the time. It's almost every day that I'm speaking to an employer for someone that I trained that I provide a reference. But I provide references for the people that come to the class, that actually do the work. And when the hiring manager says, Mike, are they ready to do the job? The answer is I say yes, because I know they are. But to get a reference from someone, it's based upon how you act, how you do. Can you guarantee 5 years from now that you would show up to every single class, do every single thing you said, not miss a beat, not get a new job, not have to move to another country? And the answer is you cannot. And that's really the key. You're asking if I'll be here. I'm going to be here. I'm not going anywhere, but I can't guarantee that you're going to do the steps that are necessary for you to ask me as a reference in the future. I hope that makes understanding. Because if you go out there and commit a massive crime and somebody says, Mike, is this a safe person? And I said, I don't know. They just got arrested for murder. They killed 10 people. And I don't believe that's you, but I kind of hope you understand we have to go out there and we have to be honest. We have to be ethical in what we do. And I used a ridiculous, exaggerated situation for fun. But that's the point. I'm not going anywhere. I'm going to continue to do the things that I do. But here's the reality. My goal is training people and getting them hired. That's what matters. And when they're hired, you know, they can go out there and their employer can sign whatever letter they need to because they're already hired. And I want to create an environment where you don't need me 5 years from now. You come to me for professional development, and you come to me to earn your next $100,000 or $200,000 or move into that C-suite position, because that's what I like to do. But I'm not going anywhere, but I kind of hope that makes sense. I provide lots and lots and lots of references.
As long as you do the work, Scooby, and as long as we can make sure that Cindy doesn't make Mike go into a second retirement, so to speak, if she wants more cuddles and so forth. For a matter of fact, his wife might do so too. But in general, we'll try to be around as long as possible. Yeah. That's our dedication. That's our mission. That's our objective as well. In either case, everybody, fantastic questions. Keep them up. Whatever questions you have, make sure you pop them into the chat box as well. And aside from that, we'll get back to Mike and let him finish up some more content in regards to secret management before we move on to our next bigger topic.
So now we're getting into operations. In this operations, we're going to talk about data center design. So let's face it, data center spending's going up, cloud spending's going up, security spending's going up, mainframe spending's going up, and AI spending's going up. So kind of think about what that actually means. Now, data center spending is also going up, which is the greatest news in the world for cloud architects and cloud security architects, because now we now have our data center running cloud software, 2 or 3 public clouds, and now everything's hybrid multi-cloud, which adds a little bit to the complexity, which means more job opportunities for all of us cloud architects, cloud security architects, enterprise architects, AI architects, and all the most exciting things there. And we're all going to have our data centers to some degree, or many businesses will have their data centers, because for high-performance computing, it's much cheaper. For systems that run 24 hours a day, it's much cheaper. For systems that need maximized security and micro-segmentation, we have many more opportunities in our data center than we do in the cloud. We combine that with the agility, the scalability of the cloud, and we've got some incredible digital transformation we can provide our customers, which is great. We always need choices. We always need options. So let's talk about robust and resilient design. When we're dealing with a cloud data center, and realistically speaking, your own data centers, they have to be able to withstand a natural disaster, a hacking attack, an infrastructure design, a utility outage. You can't have a data center that goes bye-bye because the power fails. And honestly, in my 25 years of designing data centers, the only data center I've ever seen in my life that had a power failure that took systems down was AWS. And I've never seen it before because typically speaking, you have multiple, multiple power companies coming in whenever possible. You've got generators, you've got batteries. So I've seen it in companies that don't have sophistication in their technology, but a well-designed data center, I've actually never seen power take a data center out in 25 years except for that AWS availability zone because of the way they're typically designed. And in that case, AWS said their power management systems are what broke, and that's why their other systems didn't come on. So when we think about data centers, not every data center has the same level of design and level of availability. So every business has its own level of downtime that it can tolerate. 5 nines, which is 99.999%, is typically the gold standard when we're dealing with high availability, and that means 5 minutes and 15 seconds of downtime. And let me make it very clear to you. 99% of the architects out there would have no idea to design a network system that could be 99.999% available. Some of us have done it. I have done it. We are talking about massively expensive infrastructure. We are talking about redundancy everywhere. We are talking about resiliency everywhere. We are talking about controlled protocols, procedures, testing long before organizations have made change. Now, if you're running a bank, that bank probably needs 5 nines availability. If you're running an air traffic control system and planes are in the sky, that thing needs 5 nines availability. If you're running an emergency service like dial 911 in the US or 9999 in the UK, we need 5 nines availability. But what really determines what kind of availability we need is, going back to this business impact analysis in the first day, what is the cost of downtime and what is the maximum tolerable downtime? Everything is based upon those calculations. Now, we're designing a data center. We have to think about everything. So, the building, how the building's made, environmental best practices. I mean, if we're near a forest, maybe we may need to maintain that forest so we don't get affected via forest fires, for example. So, we need to make sure that every component of the data center and its operations is going to work and be reliable and be robust. So designing your data center and building your own cloud is the equivalent of building a house. Going to the cloud is the equivalent to checking into a hotel or renting an apartment. So there is going to be some big expenses in building your data center. But, and here's the but, it enables you to customize your location, customize your service, customize your design elements. It's highly suitable for organizations with more complicated technology needs. It gives the highest performance. Generally speaking, lower overall cost for those that can afford it in the first place, and generally speaking, better security. So this is where your architects need to have some good business acumen, and they can actually look at whether it makes sense to do these lease or buy calculations and run all those ROI models that are necessary. So we have to really look at it. Maybe but instead of a data center, the organization uses a co-location space. So what's a co-location space? These are data centers where maybe you purchase a rack or two when you put your information there, or you buy a cage and you put your gear in there. So that could be running systems. That could be in another type of a cloud provider, even though they don't call themselves cloud providers. So if we have to build it, there's the initial cost versus the long-term leasing costs of being in the apartment. Now, building it ourselves, it's a capital cost. Now, we can finance those capital costs the way you get a mortgage on your home to build out the data center and really minimize that. And then when we consider the financing cost of building out the data center, the financing cost of running out all the equipment, we may find that each month is substantially lower than leveraging the public cloud. But a lot of that's going to come for where we build our systems. Getting power into a data center can be something that can be millions of dollars or more, just running the power under the ground. Or if it's in the right space, it could only be, a couple $100,000. Now, getting the networking connections could be very expensive if you're in a remote area where there's no fiber under the ground. It could be incredibly cheap in certain areas too. So we have to think about that. We also have to think about the scalability of the data center. We only have a fixed amount of space in the data center, so how do we scale it? At some point, we put bigger servers in them, meaning more CPU cores and more DRAM, and we stack them up as high as we can. Now, we also have to think about power and cooling technologies and staffing. So a lot of ventilation needs to go in these data centers. They take a lot of power. So if you're ever curious about how to calculate the heat output, there's HVAC formulas where you can convert power in watts to the amount of heat that's generated in terms of, say, British thermal units. And it's directly proportional. If we remember that law of conservation of energy, we learn that energy cannot be created nor destroyed, merely transformed. So you got 1,000 watts of power, you're going to have 1,000 watts of heat. Now, you may need 5,000 watts of power to power a gas car, an electric car, a diesel car. It's all going to take, for the most part, the same amount of power. And it's going to generate the same amount of heat because energy cannot be created nor destroyed. So think about that when it comes to building your data center. So on security, we have to think about what kind of security we're going to need for the data center. What does that mean? Do we put it in a remote area? In which case we've got a lot more security, where maybe we have some natural resources that can secure the entry points down, but it makes it more expensive to bring in the cabling. We could do that. Do we need good entry and exit, the ability to get in and off to our data center? Do we need that? So we have to think about that. We also have to think about staffing. When it comes to our data center, can we find the right resources? Can we find those people that actually know? If we can't find them, maybe we outsource them to a third-party provider like an Accenture or an IBM that can run it for us. And maybe they can run it better than we can with our own equipment. So we're always looking, whenever dealing technology, is strategic alignment. Does this data center get the business in a better position than the cloud? And if it does so, does it do it better, faster, cheaper? What do we gain? What do we lose? It's all a series of things to think about. What about the agility of the business, or if that business needs to move? If we know we're going to build a business in a certain environment because it got some kind of a special tax favorable break to go build a business in this environment, and they're not going to have any taxes in that environment for the next 30 years, well, it's going to make sense to build a plan to try to be in that environment for 30 plus years. But what if they want to be in an environment for a short term? And maybe it makes sense and maybe it doesn't when we look at all business factors. But maybe they're going to be in this market for a year and then they're going to move somewhere else. Well, then it doesn't make sense to build a data center. Go use the cloud from the beginning and potentially think about building a data center later. So everything we need to think about is related to long-term needs and what we're doing and how we're getting there. So when we think about data center locations, can we get electric? You're probably not going to put a data center in California where you're going to pay 40 cents a kilowatt hour for electric. But you might put it in McPherson, Kansas, where it's 5.6 cents per kilowatt hour if you're going to be using millions of power watts. Can you get high-speed connectivity? I mentioned McPherson, Kansas, which is this cool little city in Kansas. I have a friend that went out there. I spent a couple of weeks there, and I truly loved it. It was really cool. They had a lot of fiber under the ground. It was truly amazing. They had super cheap electric, and they had access to pretty much everything you could cool, and I made a lot of friends there, and I absolutely loved it there. So low-cost electric and good bandwidth. Well, that was a beautiful environment to put a data center for the first one I had built out there or designed out there, which I helped bring in a team of people to build. But when you think about it, what's the likelihood of a natural disaster? Am I going to put my biggest data center in Miami? Probably not, because I don't want to deal with hurricanes. And I don't want to have to deal with floods. And I don't want to have to deal with other things that might make it a little harder. I might choose other more stable environments. I'm probably not going to put a data center in New York either if I don't have to, because I'm going to have to deal with high labor costs. I'm going to deal with high regulation. I'm going to deal with high electric costs. There's going to be lots of reasons that I might look for certain environments. What is the labor availability? Can you use generic labor? Are you mandated to use specific labor, which costs you more? You got to think about all of this when you're building a data center. And then we want to just think about this. Now, when we started dealing with our cloud providers, we have to think that they're very vertically integrated at this point. So they're designing custom hardware. Now, AWS, Azure, and Google have all invested in nuclear power plants to some degree. Microsoft is rerunning the old 3 Mile Island. Google and Amazon are investing in mini nuclear reactors to power their systems. Now, from an infrastructure perspective, does that have the utilities we need? Can we get water in there if we need to? Can we get heating for the people that are there? Can we get staffing? Now, when we're dealing with our data center, can we get natural gas? Because if we can, now we've got a beautiful long-term power situation. We've got 2 power companies coming in. Power companies can't make it. Power goes out. Natural gas kicks on our generator. They're smooth. Everything's running great. If we don't have natural gas, maybe we need a diesel generator. And that means storing thousands or tens of thousands of gallons of diesel and making sure that if something happens, we're there. We're going to need fire suppression in our data centers. We're going to need everything. We're going to think about every aspect of keeping that there. So small to mid-sized organizations may find having a dedicated data center to be somewhat challenging. And the cloud's going to be more agile. A big organization, it's funny, 2 years ago, JP Morgan Chase said they were saving over $2 billion a year by running private clouds versus the public cloud. And then recently, the availability and the ease of AI made them adopt the public cloud. So lots of decisions go back and forth. But realistically speaking, the data center versus the cloud is just a build versus rent approach. So the decisions that organizations make is to examine the financial feasibility, examine the staffing capabilities and considerations. Do they have the sophistication? Can they find the people? Do they need it? Do they know how? What kind of resiliency capabilities do they need? And if you're going to build it, you connect to multiple power grids. We have to make sure that no single event can take it down. So different internet service providers, different wide area network power providers, cooling systems, redundant networking, redundant everything. And I talked a little bit about generators, but generators are going to generate your power during the outages. And they have to be powerful enough to sustain millions of watts. And they need to be deployed redundantly. So all of a sudden we're on generator powder and one of the generators kicks out. We can't be losing everything, right? And we need to potentially, maybe there's an emergency and maybe the power's down for a week and we need to be able to keep these systems up. Now, for many businesses, we can deal with maybe UPS systems, which are basically batteries. Well, they're basically like a power strip, which would have a battery in it. Now, these UPS systems can get pretty big and they can have a whole heck of a lot of batteries. Now, organizations will typically use batteries and UPS systems with generators. And realistically, what's going on is the power's coming in from the outside or potentially the generator. It's not going to be the smoothest, cleanest power in the world. So it typically goes to UPSs or power conditioners and they smooth out the power so we don't be burning up our servers. And they also typically have a battery backup time of a certain number of minutes. And that way, for example, if the generators didn't kick in for a couple of minutes, there's some power reserve should somebody have to play with the generator. So data centers often have some batteries to cover them as well. And they also clean and condition the power. Now, we're going to build a data center. We have to have a lot of redundancy in our communications, don't we? Because we have to first figure out what the bandwidth needs are and who's communicating and connecting with whom. That means looking at our current requirements and our future requirements and determining what internet service providers we can actually get, where we're at. We're obviously going to need more than one, because if we deal with one internet service provider and they have an outage, we've got nothing, which is a problem. We want to make sure that our internet service providers don't have dependencies on the other ones. So we're not dealing with one internet service provider that's dependent upon our second internet provider to work, where if one of our internet service providers goes down, we lose both of them. You'd be surprised. And we're constantly needing to evaluate our connectivity, our redundancy, our system design, what have you. Now, we're also going to be thinking about water supply. Now, there are some environments where we use water loops and cooling data centers. We may have backup systems related to water. And we may also need water for various types of fire suppression, ideally not around our computers. So there's lots that goes into fire triangles and fire management. But from a water perspective, there's lots of reasons we may actually need water. Now, we will potentially need gas for heating if we don't have enough power. We will also need potentially, whenever possible, natural gas for generators. We're going to talk a little bit about physical security. So we're going to want to use, with physical security, the principles of defense in depth 2. We're going to have multiple security layers. So if you enter a building and they have you walk through a turnstile, that turnstile is a form of security, because they could lock you into that turnstile if they want. Then potentially you see a security guard. Then potentially you swipe a badge. Then potentially someone needs to check with you, multiple layers of security. In a high security environment, you may have to walk through a turnstile. You may then have to present a badge or something, give your bag to a security guard, have them metal detect you, have them x-ray your bag. Then from that, you could be placed on another step. You could be sniffed by a dog, and then you could basically have your credentials checked. Then you might need another key in the elevator to get to your location. So we can do lots of levels of defense in depth with regards to our physical security. And when we think of controls, we've got physical controls, administrative controls, and then logical and technical controls. So from a physical security perspective, we can put fences in. We could have guards running around patrolling the neighborhood. We can have cameras doing video surveillance to watch and see what's going on. We can do electronic monitoring. And, one of my favorites is have dogs run around. They'll find stuff. They'll go catch everything. So we might use them all. Why not? Depending upon the security needs we have. Now let's talk about controlling our entry points. So we may not want people to be able to come into 50 different doors in the business, because that's going to be hard to secure. Maybe we've got 1 or 2 controlled entry points, and maybe there's guards on those entry points, if you will. Or we've got a reception with the sign-in log and video surveillance and facial recognition system that's verifying the people are who they claim to be, in addition to their badges. We may have monitoring systems in place or alerting systems in place. We want to make sure that we secure our electrical supply, our storage, our distribution components, and we want to make sure that our generators and fuel are kind of away from where the people are and maybe where the cars are going to be. Inside of our building, we may have access controls like keys or access codes or secured doors. We may have some sensitive assets that we desire to protect, and we should be doing some kind of tracking with them. We want to make sure that we've got good fire suppression in place, and make sure that if we've got a fire, that we can find a way to fix that fire, and ideally do it in a manner that doesn't destroy all the electronics, if and whenever possible, or be a harm to people. We also want to make sure that even if something happens, like the power goes out, or we've got a problem in the network, that we still have security. So let's talk about securing the data center. So who do we allow into that system, which has got all our servers, all of our storage, and all of our business data? Well, you get the concept. These are the kind of things that we need to think about and we need to talk about. So we have to limit access to who can be there. Only the people that need it. It goes back to that principle of least privilege. Don't put people in a position where they don't need to be. I think we need to control and monitor everybody that goes in and everybody that goes out. We want to lock the racks and make sure that people can only go in for a certain period of time, or whatever keys we were to use, or only for the duration of their units or their usage. Let's talk about SLAs and resilience in our systems. We want to make sure that we've got SLAs with whoever our providers are. Maybe they're our network providers, our internet service providers, our cloud providers, so they can come close to guaranteeing our needs, and if not, they can give us some money back. Now, remember I said that not all data centers are equal? And then I've seen highly available data centers, and I've designed these super highly available data centers, but there's various tiers of data centers. So we're going to talk about data center tiers. And realistically speaking, there's about 4 tiers. And as we move up through the tiers, we've got data centers that's got much more control into their power, their cooling, their maintenance, their fault tolerance. And we're going to be dealing with tiers that are going to match the business needs. And higher uptime requirements are not necessarily better. For example, if a business spends so much creating high availability that it goes bankrupt, it's not necessarily the approach. So it's all based upon the business's needs, cost of downtime, what have you. So a tier 1 data center is as follows. Basic infrastructure. Maybe it's got a UPS for line conditioning, and maybe it's got a little bit of hour backup. Maybe you've got upwards of an hour backup, and you've got some dedicated cooling. So this is not a robust, super high availability data center. Something you might have in your house, for example, or in a small business. Now, still, if we add a generator to this data center, and now we've got basically a generator which kicks in during an outage. We've got some basic UPS systems. We're connected to a single power company here. And we protect against human error. We can get this type of an environment down to about 28 hours or 28.8 hours of downtime per year. And that's considered 99.67% available. It's not terrible. It's not good. Not real challenging, but the key here is it's fairly low cost. Now, the next thing we find ourselves in is in a tier 2 data center. Now here, we've got real heavy-duty generators. We've got strong UPS devices. We've got all kinds of cooling units. We've got pumps. We've got fuel tanks and storage if we don't have natural gas generators. And here we're going to really try to build for high availability. So that's what we're actually going to be dealing with. And here we can get to 99.741%. We make sure that we've got critical operations that are not addressed by unplanned things. And we can keep that one single environment down to about 17.8 hours of downtime per year. So not that bad for a single environment. But we're never going to deal with a single data center when we want super high availability. We're usually going to use 2. Now, we can get into a tier 3 data center. Now we're getting pretty robust. And my life has always been on tier 3 and tier 4 data centers. So in a tier 2 data center, you've got a lot of redundancy. You probably have 2 power companies whenever possible. You've got good generators. You've got good power. You've got strongly, highly redundant networks. And you've got multiple paths in and out and no single point of failures and highly resilient systems. Now you're dealing with a very high availability data center. And realistically speaking, you can get to about 99.98% available in a single data center like this. This is a robust data center. You're dealing, assuming people don't make silly mistakes, with about 1.6 6 hours of downtime per year. So this is a good data center. It's a high-load, robust environment. Your cloud providers' data centers are typically a little better than this. Now, a tier 4 data center, which is not something that everybody's necessarily done, we may be working towards them. We're in that tier 3, tier 4 sort of state. Now here, highly redundant in everything you could potentially think about. So maybe 5 ASPs, maybe 5 different WAN providers, 2 power companies, 2 sets of generators, 2 sets of power, backup air conditioners, backup everything. Now we've got a very high availability data center. We've got a change control process. We've got a process for a process for a process to a process to a process. This is where we're at if we're creating, say, a utility. Now here we can build some very available data centers. Realistically speaking, we can get them to about 99.995 or about 26 minutes of downtime per year. So an organization that needs very high availability might build 2 of these. And realistically speaking, you combine 2 of these together, you get to that 99.999% available time relatively easily. So I think that's a good part to stop for today. Tomorrow we'll start with shared data centers and tenant partitioning and all kinds of really fun stuff that's associated with that. So let me stop here. Let's answer a few questions before we go back to new questions. I want to make it clear that on Thursday we have the How to Get Your First Cloud Architect Job webinar. Come join us. And tomorrow night, Mark and I are going to, or me, at least me and some other person from my team, we will answer some questions that are complete. I'm sorry, it's Wednesday night. I get my days confused because I pretty much do the same thing every day. On Wednesday night, we're going to have a question and answer session for anything related to any career question you want us to ask anything about anything. We'll be able to question you on Zoom, have that back and forth dialogue, and really get to the heart of what you're looking for. And we'll do anything we can to help you. And it's all free. So register for that. And I'll put up Chris on the screen real quick because he knows much more about that, and we'll on that as well, or at least Mark will, and then probably potentially before Chris leaves. Okay, Chris popped in the chat box. Great.
Yeah, Chris already beat me to it. Some of the additional links that you all can take advantage of it. I want to say specifically because it just popped in my mind. Scooby, I believe it was Scooby who mentioned the question in regards to artificial intelligence. While it's not a full-blown course, if you are interested more about artificial intelligence and kind of want to get the head start on your learning progress, there is a free ebook that you can register and download for in the description box in regards to the career guide to generative AI. So that'd be something worthwhile. Aside from that, please give us a hashtag CCSP. Let us know that you enjoyed today's session. For those that it might be your first session today, we kind of gave a little bit of a idea what you can do. If you want to review some of the other 5 sessions we had last week, make sure you go to the main channel of Go Cloud Careers. Under the Live tab, you'll be able to look at the live sessions. I know sometimes YouTube can be a little bit confusing when you're trying to find previous sessions. In this case, it's going to be under the live session. Now, are you up for one question, Mike? Before we...
Why not?
All right. So this is from yourself. Under which tier do edge location data centers fall, and how common are they?
So let's be careful. There's a couple of terms, edge location. So if we're dealing with the context in AWS, where we're describing an edge location according to AWS terms, that is where their content delivery network is hosted. So content delivery network, you can think of an AWS edge location, typically speaking, as an internet point of presence with caching servers. So in this particular environment, they're all designed to be between that tier 3 and that tier 4 world. AWS suggests that their data centers are 99.99% available. I'm not sure that in most years any cloud provider has actually delivered 99.99% availability or greater, no matter how many availability zones and regions you've used due to sporadic outages, but theoretically each availability zone or data center is 99.99%, which puts them squarely in the middle of that tier 3 to tier 4 data center. And we have to assume that all cloud providers are doing that. Now, the edge locations, the other thing you might be talking about, could be edge computing. And now you're dealing with a internet service provider, typically speaking, or a 5G provider like a Verizon, having a data center they run where they put their systems in there. And then potentially speaking, you put some edge computing devices there or some processing for, say, your IoT. And the cloud providers have them. And sometimes the cloud providers use the mobile phone network provider. So there's a lot of different types of edge computing environments. They should also be designed to be between that tier 3 and tier 4 space. Now, I can tell you there are a lot of internet service providers like Verizon and AT&T, and they are masters of building high availability systems, and they've been doing it for decades now. Now, notwithstanding the issues that happened last year, the software update, which took everything down. Now, I can remember the day that they were updated. They were doing a software update that AT&T, Verizon, and T-Mobile weren't talking, so AT&T said we had a software update. Internally, we were all placing bets. Did they get hacked that day? And miraculously, 100 million customer records from AT&T was stolen. I wonder if it was that day. We're still hypothesizing on that. But, kind of think about it. They're very good at what they do, but even the best of the best will get hacked from time to time.
Fantastic, everybody. Again, I hope you enjoyed this session very much. As a reminder, we're going to continue with our bootcamp throughout this week, meaning from Monday through Friday. We're going to do it at the same time tomorrow at 2 p.m. Eastern Standard Time. So make sure you do your calculations right. If you're joining us and you have not changed your time yet from, let's say, Europe or other countries, make sure you change the time. And aside from that, make sure you give the video a like, subscribe to the channel if you like what you're seeing. Take advantage of the free resources that you'll find in the description box, all from how to get started in cloud architecture, how to get your first job, how to even answer tech-related questions on an interview, why technical skills are not enough for your career, and of course, the study guide, which is going to be a supplement and a complementary tool that we're going to be using throughout the rest of this week. So again, I wish everybody a wonderful morning, afternoon, or evening, wherever you're going to be at. And we look forward to seeing you all tomorrow again. And you're all very welcome. Take care, all.
Take care, everyone. So nice to see you today. So thank you for joining us. I'm having fun with all this cybersecurity geekiness. I don't get to get this geeky too often every day as an executive, and I miss it and I love it. So I'm having so much fun with you. Maybe you can give us all a like, a subscribe, hit the bell to be notification while we're there, and another hashtag CCSP. Probably good for the algorithm along the way. I'm looking forward to seeing so many of you on Wednesday night.